What's up, you guys? Welcome back to the channel. In today's video, I'm going to show you how to build this full platformer game start to finish in Python code using the PyGame graphical user interface. So this is a pretty special video for me, first because it's one of the most complete and in-depth projects I've ever built, including saving high score and loading it in for external text files and sound, and a level editor accomplice project where you can create your own levels and make this your own. But also because I just hit 1 year of making videos on my channel, LeMaster Tech, and I wanted to start the video by just saying a huge thank you to everyone who has subscribed to the channel, liked any of my videos, left kind or constructive comments, or even just came and watched something here. All of the support has made all the difference in the last year, and thank you guys so much. So let's start with a quick project showcase while I play a bit of the game and talk about it while you can see some of the gameplay going on. So the game is a tile-based platformer, meaning there's like an invisible grid dividing the screen up into equal-sized tiles, and on my screen I have it 18 wide by 9 high. During the tutorial, I'll show you how you can customize that if you want the screens to be different sizes. It can work with any number of tiles. The basic objective of the game is for each level, collect all the different key cards to unlock the portals of that same color, and then once you have all the key cards and you get the gold key card, then you unlock the gold portal, and once you go through the gold portal, you go on to the next level. The overall scoring of the game is actually how fast you can complete the game, and that makes it pretty fun to replay and try to beat your previous scores in future runs. Using a level editor project, I created in a similar way to actually creating the game. You can build your own levels in an extremely fast and easy to do manner, and I built all of these levels in about a half hour that come with this project. And I reviewed how to build that kind of level editor project in a previous video, which I will leave a link to in the card above the video right around now, and I will also link to it in the description of this video as well. So I'm not going to go super into depth about the level editor that I built, but I will link to those resources, so if you're curious how to actually create the levels without sitting there on an array and typing in numbers, be sure to check out that video, check out that content, and that'll explain a little bit more. Otherwise, I'll just be talking about very briefly in this video. The game itself can be very easily expanded to include as many levels as you want just by adding some levels into the levels list in the levels file. We will get into that in this video as well. So don't think that just because I built mine with 5 levels, it's a 5-level game. It can be as much as you want. You can really make it your own. Since this is a pretty huge project and we're going to try to teach the whole thing in one video right here, I've included timestamps and chapters to divide this video into the different sections. So if you really just need help with one section of your platformer, check out the timestamps, check out the chapter titles, and see if maybe one of the chapters is specifically what you're looking for if you're not down for the long haul of watching the full tutorial. If you want to grab the code and all the other assets I use, including the font, the audio, all of the visual elements that I use, all of the images and tiles and backgrounds and the player animated frames, go ahead and check out the GitHub link also in the description of this video. I've left everything that I use in this game at that link, so I really hope you use it. Before you grab the code, consider leaving a like on the video, subscribe to the channel. It helps me out a lot. I spend a lot of time on these projects, and I have no problem leaving a GitHub there for free for whoever wants them. Just don't forget to show your support if you find it fun and useful as well. Overall, a ton of folks have showed a lot of interest in a platformer when I've asked for suggestions in the past. So I think this is the perfect project to make together as a thank you for one incredible year. If you'd like to get right to the tutorial, be sure to skip ahead to the next chapter of the video. Otherwise, I just want to quickly say some stuff about the past year. I started the channel with my 2 biggest goals being get better as a programmer and a software developer myself, and making learning to code approachable and fun for anyone who has the interest. I made my first videos a year ago as I quit my previous job and said, you know what I want to get more into is programming and game development and learning Python and generating Python projects. And my second goal was really I want other people to feel like it's approachable as well, maybe something you don't have formal education in, but you want to get more into. And I feel like after a year, both of those goals are going great, and that's just the beginning of what I have planned for this channel. In the coming years, I want to expand the channel to include additional programming languages, discuss numerous different engineering disciplines, start building a website for the channel and hosting some of the larger projects I make on that website, and expand the channel to include hardware builds, robotic and automation concepts, which is a little closer to what I actually do day to day. Talk more about different worlds of engineering and STEM, and hopefully just see where the channel takes us, and all the while keeping true to the roots of the channel and including tons of cool Python and various programming tutorials. Right before we start on the platformer tutorial, going line by line, I have to do a quick shout out to all of the YouTube viewers that are going to be shown on screen right now, who have been consistently leaving a ton of great feedback and comments on my YouTube videos and really helping me learn and make better content. There are so many more than I show on the screen right now. These are just some people who have really stood out as constant contributors to the channel. A lot of feedback, a lot of comments, and a special shout out to Dale T. He was my first Patreon supporter, a big part of the reason why I've kept going, and he also made the awesome key cards used in this project that you're going to see and use and download from GitHub. So huge shout out to Dale. He also collaborated with me, and we came up with a lot of the mechanics of the game and how the gameplay was going to work, which just brings me to the point: if you want to contribute to the channel, collaborate on future projects, contribute to some of the games and projects in big ways, be sure to check out the Patreon link as well. Absolutely no pressure. I'll always be putting a lot of content on YouTube for free, but that sort of support goes an extra mile. Become a super supporter of the channel, and I really appreciate all of that as well. So thank you guys so much. One incredible year. I've got a lot planned for a lot of years to come, and I really hope you guys enjoy following along, being part of the journey. So now, after that lengthy intro and extensive chat with you all, let's get right into the reason you're all here and start the full Python platformer tutorial. All right, boys and girls, ladies and gentlemen, programmers of all ages, let's get right into this project because I have no idea how long it's going to take. I do know that just the main code is around 400 lines of code, and so I'm going to explain everything, what we're doing as we do it, but it's a long project, so let's get right into it. And I'll say right up front, if you have any questions about anything I did in this video, and you want to correct it or go over it, just drop me a comment on the video. I'll get back to you as soon as I can. I'm going to try to move pretty fast, but still thoroughly explain all the concepts. This is going to be a doozy of a project, so buckle up. As always, when creating a game with the PyGame module, import PyGame in the very beginning. That's really all we need to import in the beginning for this one, and then do pygame.init, which basically initializes the entire PyGame package, okay? And then something I always like to do, technically you don't have to do this, but I like creating a width and height variable that are just going to be constants that are the size of my game throughout the game. And I'm going to make this pretty big. It's pretty much going to fill the screen. So width 1800, height 900. And then to set up my actual screen to use those dimensions, just do pygame.display.setMode. And then in the dimensions, just put width and then height in these square brackets inside of set mode. It's looking for a width and a height dimension, and put that in a variable. I always call it screen, and that's a variable that makes a lot of sense. So one more thing we're going to do, this is an optional step, but I always like to do it on big projects. You just set the caption. So this is what's on the top of the window when you load your game up. It by default says like PyGame window, but we're putting a lot of effort into this game, so let's call it space platformer. 2 exclamation marks is a little cheesy maybe, but we'll go with that. And then I'm going to set up an FPS, and what you'll actually see in this game, it's so big that the game's probably not going to be able to run at 60 FPS unless we do some optimization or you have a really great computer. I'm on a laptop right now because I'm in the process of moving, so I don't have my desktop set up. But FPS, and basically what you'll see is we're going to limit the game to not be able to run at more than 60 FPS, which just kind of evens the playing field for all machines. And then we're going to set up this timer variable, which is going to be equal to pygame.time.clock with a capital C like this. And what you'll see is we're just going to use this in our main game loop to control the speed of the game. All right. So now let's just go ahead and set up the main game loop, which I just referenced. And to do that, we're going to create a variable that's essentially going to control whether or not the game is running. And obviously when you boot it up, you want the game to be running. So we'll set run equal to true, and then we'll say while run. So now this is all the code that's going to happen every time the game is running. And we'll just do timer.tick at FPS, just like that. All right. And then what we're going to do for now is just screen.fill, and I'm going to fill it with the color black. And then we are going to handle how to get out of this main game loop. So the thing about a while loop where we have this while run going on is until you put conditions in that'll let you get out of that while loop, you have what's called an infinite while loop. Your computer would recognize that there is no way of getting out of this loop, and it's going to crash your computer. So right away, you need to put some way of getting out of the run condition. And for us, that's really easy. It's just clicking the X on the window. So we're going to say for event in pygame.event.get, just like this. And we're going to say if event.type is equal to pygame.quit, like this, which that's Pygame's built-in, you clicked the red X in the top right window. And we're going to just say if you did that, then run is equal to false. Okay, now two more things to get just the default window up and loaded is going to be pygame.display.flip down here at the bottom, but still inside of the main game loop. And then outside of the main game loop, we do pygame.quit like this. All right, so just what you're seeing on your screen here, this basic 24 pieces of code is going to let us open up the default Pygame window. So hopefully you can see space platformer at the top. We've got this 1800 by 900. If you don't want those dimensions, just make sure you change this width and height to whatever works for you. But understand, I chose 1800 and 900 because I'm going to have this tile size of 100 by 100. I'm going to divide my screen into squares that are 100 wide and 100 tall, and then I'm going to make my game board 18 boxes wide and 9 boxes high. So if you choose to change the overall dimensions of your screen, you either need to decide to have a level that's fewer boxes, or you need to change your tile size down to kind of be scaled the same way. All right, now a huge part of this game is the graphics and the visual elements and all of the tiles. And if you've already watched the Pygame level editor video, you probably know it's going to be a lot of work to load in all of the images we're using in the game. But that is what we're going to do next. So I'm going to put this area here, load images in for use in game. Okay, and this is where prep before you start a project like this is really important. So in assets, to talk quickly about my folder structure over here, in assets, I have all of my images in this folder images. I have 4 frames, which are basically my astronaut walking here. You can see it's just kind of, if you click through these, he's standing still. He's got his sort of forward arm, his dark gray arm forward, standing still again, and then his dark gray arm backwards. So just those 4 together make him look like he's walking pretty well when we animate him. And then for these key cards, these are what are actually going to let you unlock the various portals in the game. And my Patreon supporter Dale made them, so shout out to Dale, sweet key cards. But we have these 4 in the key cards folder. And we just have blue, green, red, and yellow or gold. And then I have matching portals, which are obviously what gets unlocked when you get a certain color key card. And then the last thing I have is all of my tiles, which are basically acid. And actually, I'm going to be using this acid because I don't want all of this empty dark screen above it. I just want the smallest actual practical piece of acid that I need. And then I have just the ground that you can walk on. And then I have rock, which is sort of underground, so you're not walking on that one. And then this platform in the air. So those are the tiles that we're going to use in our platformer. And then I have just a lock so that when a portal is not available to walk through, we're going to display that with the lock on it. And then I just have my logo in here, I guess, this because I figured I'd throw it in the bottom corner when we're almost done just to say, hey, we built this on LeMaster Tech. So then I made this background screen, and I made all of the images you're going to be seeing in here with the exception of the key cards, all from scratch. And I did it pretty quickly on a online tool called Canva. So shout out to Canva. They're not sponsoring the video or anything, but it's really easy to make some basic art, digital art, with that tool. So now let's go ahead and load these images in, okay? So this might seem a little boring for a minute, but getting the scaling correct and loading all of the images in and putting them in variables is actually really important, okay? So to start, we're going to do the background because that's kind of the easiest one, and we're just going to do this pygame.image.load, and then we have to point it to the right direction. So we're going to go to assets and then / images and then / and I just called it space bg.png, just like that. And that's all we need to do for the background, but pretty much all of the rest of them are going to be a little different. So like if I look at the rock floor, it is sort of still this pygame image.load, but we have to add a second layer to it because I made those images in much larger dimensions so that I could scale them down in the game. But to do that, now it's assets, images, and then I put those in I put them in tiles, and then this one, rock, would be rock.png. But this is a really big square. It's 500 by 500. So I need an additional thing here on the beginning. I need pygame.transform.scale. So I'm basically saying load the image in, but then also scale it. And I want to scale it down to my tile size by tile size. Okay, so you give it 2 dimensions. You give it how far down to scale it to your X dimension and then Y dimension in pixels. So I'm basically saying whatever size image this is, scale it down to be 1 tile by 1 tile. This sort of, you could just hard code a 100 by 100 if you were planning on following my tile size standard. But I'm going to just show that tile size by tile size works a little bit better. Because whatever your tile size, this will still work for you, okay? So we've got rock and we've got ground. Now the next two are going to be a little bit trickier because acid and the platform were not full, right? So we've got acid here and we've got platform here. Platform. Alrighty. And this, it's still acid, and actually the one we're using is acid 2. I'm going to include acid in the, just acid 1 in the full GitHub download package. So if you wanted to leave it tile size by tile size, you can make it acid 1. But what you're going to see then is this background image. You know, there's stars almost everywhere. If you have acid, it's always going to be a plain black rectangle that might look a little weird right above the actual liquid looking part of the acid. So it's a little better to do it scaled down. And then for the platform, it's just platform like this, but you'll see the dimensions on this are pretty different. So the acid and the platform are not full height. Actually, the platform is pretty close to being half height. So what I'm going to do is 0.5 times tile size for the platform, but then for the acid, it's more like a quarter. It's really pretty low. So I'm going to do 0.25 times tile size. And that's how we're going to scale our acid and our platform down to be sized appropriately for drawing onto the screen. And now the next thing we want to do is we want to get in the keys and the doors. So we're going to have these 4 variables. We're going to have blue key, red key, yellow key, green key, blue door, green door, red door, yellow door. So obviously those are all images that we need to load in separately. Unless you're going to do them all numerically, then you could set up like a for loop for this. I don't mind seeing where all my images come from, so I'm just going to quickly go through these. It's going to be pretty similar. Pygame.transform.scale, and then this is pygame.image.load, and then assets, images, tiles, not tiles anymore. This is key, cards, and then this is key blue, PNG. And the scale on these keys, they're actually taller than they are wide. So we're going to do 0.6 times tile size like this. And then for height, we'll make it a full tile size. Okay. Now, it's going to be a lot faster if I just copy that and tweak it slightly 4 times. Whoop. There we go. So let's go ahead and do these in a specific order. Blue, green, and then we'll do red, and then we'll do yellow. Blue, green, red, yellow, and then we just got to make sure in here to tweak them. We don't have to tweak the dimensions, luckily, because the image is the same. They're just different color schemes. And now we've got all 4 of our key cards loaded in, and let's just basically follow that same standard for the door. The biggest difference is the doors are actually meant to be 100 by 100, so we can get rid of this 0.6 times tile size. And instead of key cards, key blue, it is door. I thought I called it doors. What I call it, portals. There we go. Portals / and this was blue.png. All right, now same deal, and I'm even gonna put them in the same order. So blue, green, red. I forgot what I did. Blue, green, red, yellow. Alrighty. And then in here, just make sure you update them as well. Otherwise, your green door is still going to be looking at the image for blue door. So blue, green, red, yellow. All right, we're almost out of the boring stuff, and we're almost really into writing code, I promise. But we do have to get a few of these just regular images in as well. So let's go ahead and grab the lock, which is going to show up on doors that aren't yet unlocked. And to do that, I'll just start from one of these key images. So we'll say, now, instead of the lock being equal to key cards, key yellow, this is just in the assets folder as lock. Whoop, I said logo, but we want lock. And then this, we want to shrink it down in both dimensions. So the actual image that I have created and is in the folder is 500 by 500, but it's going to look way too big if we do that. So let's scale it down to 60% in both ways. And then the last thing, this is really vanity. You don't have to do this if you don't want. But I'm going to do PyGame.transform.scale. I'm going to pull in just the letters LeMaster Tech because I think it looks pretty cool. And I worked really hard on this, so I might as well throw my old logo in there. And if you have a logo for whatever game, thing you're designing and creating, then go ahead and throw yours in here as well. So now my thing is it's not a normal size like all these other tiles. So I'm just going to give this fixed size for scaling of 300/135. It's what works for me. You can ignore that one if you don't want my logo on your game. All right, now I'm going to set up a tiles list. And the thing is, I want to create a list that basically goes 1 through 13 of all the various types of tile you can have. And I want 1 to be related to like rock, and 2 to be related to ground that you walk on, 3 to be a platform, 4 to be acid, like that. I want 0 to be empty sky. So I'm taking index 0 of tiles and I'm just making it an empty string. There are totally ways that I'll talk about once we get into using it that you could do it without this. You just add like a -1 to your lookup later. That's fine. I'm going to do it this way. And if you have questions about why I left index 0 of this list empty, just let me know. Otherwise, get your rock, ground, platform, and acid in a tiles list. And then in a keys list, I'm going to put the 4 keys. Something that's just personal preference really is you can either put all of these in one big list that's all of your tiles. It will make certain parts of your game easier, as we'll get to when we're in the drawing section of this, where we're drawing the different tiles, but it will also make some stuff a little bit harder. So go ahead and just follow my standard if you want to follow along line by line. We're setting up lists of the tiles, the key cards, and then the doors. And one more thing we have to do is we have not actually gotten the player yet loaded in, the astronaut, which is pretty important because that's who you're playing as. So to get those frames, I'm going to make a list that I'm going to call frames, and I'm going to say for underscore in range. And we are just going to have 4 frames total. This is just going to be frames.append. And then here's where I was talking about if you had thought ahead and named all of your tiles with numerical values, you could just create one for loop to load your images in. But then it's not quite as clear where everything's coming from, and you would have to do some kind of create a dictionary or something. So what I'm going to do now is say assets / and then instead of these coming from images and then a folder or images and then just the root folder, it's going to be astronaut and then / and then this is going to need to be an F string because we're going to put that underscore that we had inside of this so that we can grab all those frames. Now the thing is, the underscore for this for loop is going to be 0, 1, 2, and then 3, but the frames are actually 1, 2, 3, and 4. So that's why the underscore +1 in this F string. And then instead of the 0.6 times tile size and 0.6 times tile size, we're going to do something special for the player. The player is actually a little bit bigger than 1 square, and that's by design. It just, if you think about Super Mario or any platformer that you've played, the player doesn't really obey the laws of the grid that you're up against. So for scaling this one, what we're going to do is just say, let's take the dimensions of the images, which are all, it's taller than it is wide, kind of similar to the key cards. Let's just say that it's 5 wide for every 8 tall it is. Well, I'm going to say 5 times player scale for the width, and then 8 times player scale for the height. And then this is something where if you're not using my astronaut, you might want to play around with your player scale variable here. But I promise if you have a guy standing up and down, this scaling is going to be about right for this game. And if you don't like it and you want him a little bit larger or a little bit smaller, play around with this player scale variable. And you'll see once we're drawing everything onto the screen what difference that can make. Okay? Enough of loading in images. Let's get into the actual displaying stuff on the screen. I know how tedious that is, but trust me, now that we've got all that stuff loaded in, we're really going to start rocking and rolling and going through this tutorial. Okay, so first thing is let's screen.blit the background image and let's put it on the screen. So my background image is intentionally 1800 by 900. It's the full size of the game. So just doing that, you should now get, PyGame has no transform. I'm always calling stuff transform instead of transform. At least I didn't copy that 9 million times. Here we go. Transform. All right, I think we're good. Let's go ahead and see. We should have the background image on now. And we do, and that's sweet. Okay? So next thing is going to be loading in all of our tiles and drawing them based on what's in our levels board. So to do that, let's just create a placeholder for the level right here in the beginning. And then after that, we'll start talking about how to actually change it out. But let's say the initial level just needs to be an array, which means a list of lists. And we want it to be 9 rows of 18 characters. So to do that, I'm going to use some for loops using the underscore indexer. So I'm going to say for underscore in range, and then for my width, I want it to basically be, here's the math, it's width divided by tile size. And then for the number of rows that you want, it's the same deal, but it's height divided by tile size. Now the thing is, you really want these to be integers, which of course mine are because it's 1800 divided by 100 is 8, but you may want to do this math ahead of time, or you may want to use the int operator on it. But basically this is just me showing that we're creating a list of what we'll say for the beginning is going to be a bunch of empty tiles. So 0 for underscore in range width tile size, for underscore in range height tile size. And then I'm going to boot this up once and just show you what that gives us. Okay, so if I run this and then show you what it's going to print, it's going to print nothing because I have division in here. And even though 1800 divided by 100 is 18, it's going to tell you it's 18.0. So if you want to do your math this way, the same way I'm doing it, put int, which just turns it into an integer. Okay, and now I'm going to close the window and you can see what's going on. So it doesn't display it the nicest because technically that list is just shown on one row here, but you can kind of see we just have this long list of zeros. All right, so that's not going to help us a ton, but we are going to use that level for drawing different tiles onto the screen. So the next thing we need to do is come down into our main game loop, because this is something that we want being drawn every time that we are drawing the board onto the screen. And so we are going to basically say underneath screen.blit, we're going to say draw board, and then we are going to pass in the level variable. And then we need to come up here and we're going to say draw all tiles based on value in level array. And let's define this draw board function, and we're passing in board, right? All right, so let's take a look at filling this function in. All right, so basically as a refresher, we'll just say that 0 is basically empty frame, and then start thinking about the images that we defined and how we want it to show up. So 1 is like below ground rock, 2 is like walkable surface, 3 is I think we made 3 the platform, and then 4 the acid. 5 is where the player spawn is going to be, and then 6 through 9 are keys, and 10 through 13 is doors. Okay, so that's a long comment, but we just wanted there to remind us what all the things in the board are. So now we're going to use some nested for loops for I in range, length of board, and then for j in range, length of board I. So this is how we're going to grab the values of every single tile in our board and check what the numerical value of it is. All right, so this is just saying for I in range length of board, which is basically saying for each row in my array, and then for j, which is saying for each column inside of that row. Then what we want to do is check out what the value is. And so the easiest way to do this, rather than having to type board ij a million times, board ij, just put it in a variable that we're going to call value. And now we're going to use it about 1,000 times. So you'll see why it's easier than typing board ij every time. Okay. So to start, let's just start checking what the value is and deciding what to do with it. So let's start by saying if the value is greater than 0, meaning 1, 2, or 3, and less than 4. All right. Then what we're going to do, and this is pretty easy, is just screen.blit and then tiles value. So here's why I thought it'd be pretty useful to have an empty string in spot 0, because now if we have 1, 2, or 3, we will just grab from the tiles list what 1, 2, and 3 is. So to that point, this is why it would have been useful to make the different images 1 through 13. That would make your life a little bit easier. But I think as you see, we get more into this tutorial, the real benefit of having it like this, okay? So screen.blit, and then the image that we're going to blit onto the screen is tiles at value. And then the position we want to give it, and this is where tile size is going to come in handy, is going to be j times tile size, and then I times tile size. Because if you think about this, what row you're in is going to start from 0 and move all the way to 17, right? Because counting in programming starts from 0. So if you have 18 wide, you really have 0 to 17. Well, when you draw an image onto the screen, the coordinates you give it are the top left. So basically, we're saying we have a 100 by 100 box starting at j times tile size, I times tile size. So the top left is going to be 0, 0, and it's going to fill 0, 0 to 100, 100, basically that square. The last one you could have would be row 8 and then column 17. So it's going to start at 800, 1700, and go to 900, 1800. So all we have to do for positioning these tiles is say j times tile size, I times tile size, just like that. Next, we're going to say else if the value is equal to 4, because this is kind of a special case. We want the acid to actually sit at the bottom of where it should go. So we're going to copy this screen.blit tiles value. But now the big difference is this is going to be I times tile size plus 75. So if you think back, it's going to be the 3/4 of the tile size. So I guess to be consistent, you would want to say 0.75 times tile size like this, and then make sure that that's an integer, because these have to be integer values. Now, if me doing all of this math based on tile size gets tedious for you, you can hard code a lot of these values based on having a tile size of 100. Just call us 75. That would be fine. But we're basically scooting the acid down to where we want it on the screen. Next, we're going to skip over 5, and I think that's going to be pretty easy to understand why in the future, because the spawn point is not actually something we want to draw onto the screen. It's just something we want to use. So we don't want it to be like visually clear where the spawn was the whole time you're playing. We just need to know where 5 is so we know where to start the player. So we'll jump down to the keys and then say elif value is 6 through 10, and we're going to do screen.blit, and now it's going to be our keys list, but instead of just value, it needs to be value minus 6. Because the actual index in the keys list is 0, 1, 2, and 3, but the list overall that has these keys is 6, 7, 8, 9. So you just subtract 6 from the values. That's it. It's pretty easy to do it that way. But because these aren't the full width, we're just going to scooch them over a little bit, basically 1/5. So this is going to be 0.2 times tile size, and that's just going to kind of center them in place, which looks pretty good. And that's the keys, and then this is going to be for the doors. So now we are going greater than or equal to 10, and then less than, we'll say 14. It shouldn't really be possible to have a 14, but that's okay. This is going to be portals, doors, wasn't sure what I called it, doors or portals, I'm all over the place. And then this needs to be value minus 10 in the same fashion. But this is the full tile size. So we can get rid of this adjustment like this. And we can do it just this way. And then let's introduce the lock mechanism by talking briefly about an inventory. Okay, so I'm going to come up here and start a new area in the beginning that I'm going to call game variables. Game variables. And I'm going to start by creating an inventory, which is just going to be a list of whether or not you have the 4 key cards. Now, we're just going to say they're all false for now. False, 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 and false. But the interesting thing here that I'm going to do is I'm going to say, well, only draw a key card if you don't have the key card. So what we'll say is if I haven't collected the specific key card I'm checking for, so if not inventory at that value minus 6 index, then draw the key card. But then what I come down here and do is say if not inventory at value minus 10, then what I'm going to do is I'm also going to draw a lock on the screen in this location. So screen.blit at lock, comma, j times tile size, comma, I times tile size. Whoop. Tile size like that. And then I'm going to adjust these by that 0.2 that we adjusted the keycard by, because this is only really 60 by 60. So to center it, we want to move it 20 pixels right and down. Okay, now just to talk briefly about what we just did here, because I know that can seem a little bit confusing. As long as you have your key cards in the same order you have your portals in terms of color, then what we're saying is we have these three different lists. We have the inventory, which is which key cards have we collected yet. Then we have the doors, and then we have the actual list of the keys. So what we're saying is if I haven't yet collected a key card, display it on the screen. This is kind of protecting you as the game designer, because if for some reason you put like 3 different blue keys that you could collect in a level, and you want to give the player like the option of get whichever one you can first, once you've collected that key card, all of the other keys on the level will go away, because there's no reason collecting multiple blue keys. You don't get bonus points for it. You can if you want to set it up that way. That's not how my game works. All right. And then what I'm saying is if you haven't collected a key card of a certain color yet, then I want you to put a lock over that portal in the game, basically telling the player you haven't collected the key yet. You can't come in here yet. So this isn't going to mean much until I display all of the different things that we're doing on the screen. But we're going to do that in just a second. But basically this function right here, draw a board, is going to take all of the images we loaded in, and it's going to correctly display every single tile based on any value we give it in our level. So the next thing to show off what we just did is we're going to modify this level a little bit so that we can see all of our tiles. Okay, so let's tweak this. Initial level that we set up slightly. So I'm just going to say for range 18 instead and 7 instead, or 9 instead, because I know what size my screen is going to be. I'm not planning on changing that. I showed you how you can if you so desire. But now what I'm going to do is I'm going to append a few to this level. So I'm going to say level.append, and I want to put some manual lists in here just to show all of my tiles. So I need to do 18. So what I'll do is just 1, 1, 2, 2, 3, 3, 4, 4. And then let's see. Let's skip over the spawn. We haven't done anything with that yet. 8, 9, 9, 10, 10. So if I'm doing all these twice, let me make sure I don't put too many in here. I need 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good counting. All right, and that'll show us most of them, but we got a couple more. So let's just do 11, 11, 12, 12, 13, 13. And then, I don't know, I'll make the rest of these ones. Doesn't really matter. I am just trying to do this initially so I can see that every tile works. It's a good idea to find ways to test what you've done at various intersections of your code. So now I have basically created this level. Initially, it's just 7 rows of blank tiles, but now I'm using these bottom 2 to show me everything that I have spawned in. Okay, so this is pretty cool. You can see right here, we've got this just plain rock, that's 1. This walkable rock, that's 2. The platforms are 3. The acid is 4. And they're all in good positions, right? Then we've got these cool key cards of each color. And then we've got all these different colored portals. So now what I want to do is I want to show you how the inventory system is going to work by making it so that you have the blue key card. So I'm just going to go to inventory up in the beginning. And I'm going to make one of these true, as if you've collected a key card, so you can kind of see what's going on. All right, it looks like the blue key cards have disappeared, but we know that those tiles still have that number assigned to them. They're still 6s. We're just saying, I've already collected the blue key cards. There's no reason to display them on the screen. Likewise, the lock is no longer over the blue portal. So just like that, we've actually created a game mechanic just in how we're drawing the images onto the screen. So that's a nifty little bit of programming we did there. And I'm actually going to, for now, I'm going to change this setting up the initial level stuff, where I'm actually going to make this to where I'm going to append a few things. I'm going to say 2 for underscore in range 18. And then I'm going to make this one 1 for underscore in range 18. And I guess I typed 10 because I'm a dummy, but there we go. Now what you'll see is, okay, we have these lower 2 rows that just look like a walkable platform. So it's super basic, but as we get into the next part, which is setting up game mechanics, that's actually going to become pretty important and pretty useful. So now the thing to know about your level, let's go ahead and change this to actually range 6. And I'm going to put another row in here that might seem like a bit of a tedious way to do it, but I promise you I haven't found a better way for testing yet. So let's say that 5, which is the player spawn point, right? And then just a bunch of empty squares for now. We'll use this list, I'm sure, as a way of testing game mechanics throughout. But let me see. 5, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, because I started counting from 0 because I'm totally a programmer. I'm just going to let this guy reformat himself. But this is actually important. It's not going to look any different when I load this in, but what I have now is I have a 5 over here, and we're going to use that to spawn the player in, because the next thing is going to be drawing the player onto the screen, okay? So let's go ahead and take the position. Let's look at our level and figure out where the player is supposed to start, okay? So to do that, I'm going to make a new for loop to basically check what tile has the starting position in it. And I'm going to say for underscore in range length of level. So again, I'm saying I need to go through the entire list in the very beginning and then find out where if 5 in level. Okay, so this is basically the easiest way in Python to check if starting position is inside of that level, all right? So for underscore in range, length of level, that's a for loop that's going to go through every row. If 5 is in level at index underscore, then that means that somewhere in that row we have a start position. So then what I'm going to do is I'm going to create a new variable called start position, and I'm going to say it's x and y coordinates in I guess non-pixel coordinates. These are like in your coordinate grid, what your row and column in the array are, is going to be equal to underscore, which is saying what row I'm in, and then the second one is going to be, or sorry, yeah, what row I'm in, and then the second one is going to be level of underscore dot, and then you use this built-in index checker for the value 5. So this, I'm going to just rephrase what we just did here because I know it can be a little complicated, and I'm using these underscores because I have so many for loops. If I used I every time, it would just get old because I like using I inside of functions, and then it would like be like, oh, you shouldn't use this. You referenced it in the outside world. Anyways, what I am saying is check through the entire level. If there's a 5 in that row, then I want to pull out what the index of 5 is in terms of what column it's in, but then I also want to have what row it's in. So this is actually in terms of, let me say it here, row and then column. It may make more sense to you to have column and then row. That's fine. Just flip these two. But now I have a tuple for start position that is telling me the x and y of where the player is starting. And so I'm going to create 2 new variables, player x and player y, and these are going to be equal to kind of the pixel coordinates of where I want the player to start. Okay, so we're going to say is equal to start position at, and then you need to know that your x is based on column, so it needs to be start pause at 1, and then just times 100. So because the player is pretty close to as wide as a tile, this works out pretty well. You could make this whole thing in terms of tile size as well if you wanted to. I'm using 100 here because my player's a little non-standard, but you can play around with this thing for sure if you want to, okay? Now the player Y is going to be a little different because I do have my player scaled to be taller than 1 grid. So basically what I'm saying is start position 0 times 100 and then minus, and I'm moving it up the board now. So minus 8 times player scale. I thought I called it player scale. What did I call this? Let me go down. I did call it player scale, but I've got it defined a little too low. So this is an important just quick note about Python. You got to have a variable defined before you call it later in your program. So if I want to use player scale in my adjusting the x and y start coordinates, I've got to have it defined already by the time I call it. So player scale minus 100. And now that I'm saying that, I think the better thing to do would be move all of these down into game variables, including player scale. I'm sorry for moving you around so much, player scale. Okay, and now what we will do, actually, now we're going to have an issue with our load in. Good grief. Because of what I just said. So we'll move game variables up here. I don't see that giving us any issues. I also didn't mean to shrink you. All right, so we have now an X and Y start position for our player, and also something that we're going to want later once we're teleporting through portals and everything is we want to track where on the level we started. So while we move around, we're going to update player X and Y, but we are not going to update initial X and Y until we have moved on to the next level. So basically, this is going to be when you load in a level or pass through a portal, we'll update these initial values. But other than that, they're just going to be storage spots because, like, if you run into acid and lose a life, we're going to teleport you back to where you started on that level. So this is kind of a neat, easy way to snapshot. It may look like they're the same, but as we start using these in our game, you'll see real quick they are not just the same, okay? So let's go back down and let's add a new function below our draw the board, and let's actually draw the player now, okay? So down into our main game loop, they're going to want me to get rid of one of these blank lines, I bet. All right, so we've got draw board, groovy, and now let's draw the player, okay? And we are going to just, for now, just leave it like this because all we want to do is get the player drawn on here. So draw astronaut and define draw player. Okay. And what we're going to do for draw a player is pretty easy because we only have 4 total images that he could be in. And for now, we're not even doing anything with a mode, like is he walking, is he moving, or is he idle. So let's just start by saying screen.blit and get him drawn in the right spot. And let's draw the idle stance for now, just frames at 0, just so we can get him in position, all right? Screen at 0, and then for X and Y coordinates, it's going to be those X and Y decimal values that we just gave. So player X and player Y, just like that, all right? Now, this may seem too simple, too good to be true, and it absolutely is, but let's go ahead and load this up anyways and see what happens. So you can see I've got this groovy little astronaut in the bottom left here. I think he looks sweet. He looks like a good size to me. I'm going to keep using it this way. Feel free to pause the game at this point, pause the tutorial, and mess around with sizes and styles for a bit. I like him down there. And you can obviously tell those adjustment factors we put in work pretty good because 0, 0 of the tile we assigned his start to would be right about here. So he looks really good there. So I think all our adjustments worked well. But now we need to start building. We need to think about the player. What do we want in here? We want a few variables. We want to know what direction he's moving because he needs to either go left or right. And then we also need to know the mode, which I'm just going to say mode, M-O-D for, because we need to know if he's idle or if he's walking. So he'll always be facing a direction, left or right. But then we also need to know, is he walking or is he idle? And that's going to be stored in this mode variable. And then while he is walking, we want this counter to be going to tell us how long has he been walking and cycle through the frames that way. So we're going to need to pass in 3 variables, a counter, a direction, and then a mode. And basically, if the mode is not equal to, and we'll say idle or walking, right? Those are pretty much the 2 modes. You could add different... I guess, different modes for like jumping, falling, crouching if you had a game where crouching was a factor. Mine is just going to be he's walking or he's idle, even while in the air. So if you're just going up and down, it'll just be the idle image. And then if you're moving in the air, we'll keep him moving as if he's walking. That's how I've designed it. That's how I'm going to do it. And then we'll just check this direction. So if direction is equal to 1, which we'll say is right, so he's moving right, then we'll say screen.blit frames, and let's say this counter is basically going to be what, I don't know, 1 second. We'll play around with the counter, but we'll basically say the counter, and we want it to change every, I don't know, 5 frames will look pretty smooth. So you think about like a game that runs at 60 FPS. Well, this would change frames every time the count went up 5. So we have 4 frames, which basically means we're going to want to set this count up in the outside world to do 20 cycles so that it goes through our 4 frames. We'll do that right after we go through this up drawing the player function, okay? So now this is actually really cool. We're saying if the direction is 1, then kind of cycle through the frames just as we loaded them in. And then we'll just say else if direction equals -1, or really just else, because in our game, you're only going to be able to face left or face right. If you had a game where there were more than that, then you just go ahead and change this as you need to. But I'm going to just show you pygame.transform.flip. We're not even going to load in different frames for if we're going left. We're going to use this pygame.transform.flip to take the same frames. And then all you do is, in addition to what frame you're drawing, you just say true and then false. These are 2 arguments saying which direction you want to flip it in. So true means flip it in the X direction, and then false means flip it, do not flip it in the Y direction, okay? If for some reason you were like going up and then going down, like I previously made a game called Penguins Can't Fly on this channel where the penguin falls and then bounces and then falls and then bounces. In that, I flipped him in the Y direction while he was falling, but I left it alone in the X direction. So anyways, that's pygame.transform.flip. Neat little aside. But then what we'll say is else. So now he is idle. Okay, we're still going to check if my direction is left or right. But instead of cycling through based on a count, we're just going to draw the idle frame on the screen. Okay, so that's pretty easy. But now you're thinking, hey, you just decided we're going to have a direction variable, a counter variable, and a mode variable, and none of those exist yet. And you're absolutely right. You guys are so sharp. Let's go ahead and make those. Okay, so counter is equal to 0. What are the other ones? Mode is going to be equal to idle when we load the game in. And then direction, we'll start them out facing right. So we'll say direction is equal to 1. Okay. Now we come down to the variable, to the location where we call the function, and we need to give him 3 variables. So we give him counter. The second one, I believe in order, was direction and then mode. Direction and mode. And what's great is if I load this in, it's not going to look like anything changed. So we just did a lot of code and nothing appears to have progressed yet. But that is only because we are not moving him. All right. So we're never changing the counter, which actually, yeah, the counter we start at 0. So what we want to do is come down right after we do timer.tick, and let's start changing the counter. So we say if the counter is less than, and we'll say less than 19, because we don't want to unintentionally get to a point where we have index 4 in a frames list that only goes up to 3. So if it's less than 19, then counter plus equal 1. Excuse me. And then we will say else counter and set it back to 0. So counter equals 0. Now what's pretty cool is if I just in the very beginning change the mode to walk, all right, then when I load this up, hopefully, there you go. It looks like he's walking. And I think it looks adorable. I made these, so I might be a little biased, but I think that animation looks great. Our astronaut looks like he's walking. And now what you'll see if I change this direction to -1, meaning left, and I load this up. All right, now he's walking in the left direction. I mean, I think that is terrific. So if I change this back to idle, and I want this to stop popping up so large. If I change this back to idle, now you'll see, and it's a little hard to tell, but I think pretty clear, you'll see he's facing left, but he's not moving because he's idle. So we'll put this back to all of its defaults, and we'll just say mode equals idle, direction equals 1, counter equals 0. And let's handle some player controls that are going to change what direction we're moving and what the mode is based on the arrow keys, right? So that's how we'll control moving to the left or moving to the right, okay? So we'll come down into our forEvent.pygame.event.get, and we're going to add a new event type. And this is going to say if event.type is equal to pygame.keyDown, just like this, okay? And if the event is equal to pygame.keyDown, then we then need to check for a few specific keys. So if event.key is equal to pygame dot, and then it's k underscore, and the two we're looking for right now are right and left. All right, so let's start with right because the code is going to be very similar for left. Well, you've pressed right, which means no matter what, I should be facing right. And then I'm going to set the mode equal to walk, just like this. And then I'm just going to copy this whole thing, Control C, and say elif pygame dot left, just like this. And now direction is -1, but my mode is still going to be equal to walk. So this is cool. But now maybe you're thinking, if you're sharp and you've seen some PyGame tutorials before, I need to send it back to idle when I'm done, which means I need to check key up and still say if the event key is equal to pygame.right, well, I don't need to change direction anymore because you're assuming that the direction will be set by whatever key that you pressed last. Well, then the mode is going to be equal to idle from then on. Okay, so basically I press right and he starts walking, and I release right and it goes back to idle. So, and it's not key up N, it's just key up. All right, so let me just test this real quick. I'm going to hold down the right key, and it looks like he starts moving to the right, which is awesome. Now I let go of it, and now I hold down the left key. And he turns and he starts trying to walk to the left, okay? So we're going to add player movement next. But basically, this is a really, really good start. And you can see even after I let go of the left arrow key, he stays facing left because the only way to turn left or right is to press that key. One thing that I really think can be improved is, let's say I was holding down the right key and then I press the left key to start going left and then I release the right arrow key. He still stops. But as a player, you probably know that would be sort of frustrating because I have now tried to start going left and I'm still holding the left key, but I then release the right key. So what we want to do is just check, is the last directional control that I gave it to the right? So we're just going to say and direction is equal to 1, or and direction is equal to -1. This is actually a really significant gameplay improvement, and I hope that makes sense to you. Let me know in the comments below if you need further explanation of what's going on there. All right, so I think the next thing we're going to want to do is actually change the player's X and Y positions based on, well, we'll start with X position based on the direction that we're giving the player. Okay, and to do that, we are going to come up, and I'm just going to do this in the main game loop because it's some really basic code. So I'm just going to put a little handle X direction movement here. And I'm going to, because I know you guys like comments on my code, and I'm going to check if mode is equal to walk, with a little extra, then I'm going to check what direction I'm going. So if direction is equal to the left and a few other things. So and player X is greater than 0, meaning that I'm on the board somewhere. So you don't want to let someone walk right off the screen, at least not for my game. I'm keeping it bounded by the outside bounds of the screen in the X direction. So basically, if you've told me you want to go left and you're not all the way against the left wall, then what I'm going to do is I'm going to say player X minus equals X speed, which actually I'll just call player speed. Because we'll call Y speed gravity. So the only direction you're really in control of is player speed. So then we'll say elif direction is equal to 1 and the player's X coordinate. Now this one's a little bit trickier, and it may honestly take some guess and check if you're not using my exact characters. You just want it to let him move as far to the right as he can before it looks like he's colliding with the right wall. So I'm just going to say less than width minus 70. Because I've noticed that his actual dimensions appear to be about 70. It looks like the helmet is colliding with the right at about 70 pixels wide. And so this is saying basically the same thing in the opposite direction. I'm going to let you keep moving to the right at player speed, player_speed, as long as you have not gone all the way to the right edge. And you may be saying, Pete, we don't have the variable player speed. You're totally right. Let's go make it. Player speed, and make it whatever you feel is fair and fun for your game. I've found that too slow and the game feels really monotonous and boring to play, but also if it's too fast, then the game can become either a little bit easy or out of control and hard to control. So I've found a pretty sweet spot at 10. I like it. Let's go ahead and see if he moves. All right, I can move to the right, and the speed feels about right to me. It feels pretty good. I can tell that once there's jumping and obstacles, and yeah, there you go. Collision with the right looks pretty good. Let's see what collision with the left wall looks like. And it's pretty good. Okay, and even though it looks like he's walking on a platform, which is great, if it was just pure sky underneath his feet, it would still look like that because we haven't put any way to detect collision. And we also haven't put in any way to check gravity, like if I'm jumping or not. So what we need to do is we need to handle collisions in both the X and Y direction, because we don't want to be able to walk through solid platforms, and we also want to be able to jump but then land on solid platforms. So let's go ahead and take a look at collision detection next. Now that we've got X and Y movement going, and it looks pretty good to me. Okay, so I suggest we do a new thing that says colliding, and we'll put it right underneath our X directional movement. So we will check for collisions with tiles. Alrighty? And so what we're going to do here is we're going to say colliding, which will be a true-false variable. And then door collisions, which is going to be a list of the doors. And we're going to create a new function and just call it check collisions, okay? And so we need to come and we need to make this colliding and door collisions variable in the beginning, just so we know what kind of data to expect. Technically, because they're defined right here by the function, you could get away without this, but I like putting all of them up in initial variables. So colliding initially we'll say is equal to false, and then door collisions is going to be a list of all the doors and whether or not you're intersected with them. The reason for doing it this way rather than just saying yes, I'm in front of a door or not is because this way I can check what door I'm colliding with, excuse me, what door I'm colliding with, and do I have that key card yet? So let's come back down, and we need to make this check collisions function. So let's come down here and check collisions with tiles. All right, define check collisions, and right off the bat we know we need to return door collides, and the first one was just a true false that says collide. Okay, so yes, we need to make those, but we are already remembering that door collides is going to be equal to, when we load in here initially, all falses. False, 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 and then collide will initially be false as well. So here's where you really don't have to throw them up in your game variables list, because you're initially defining them every time you call the function anyways. You want the function to prove that you're colliding with something every time you call it. Okay, so let's go ahead and create this check collisions variable. And because it's a little bit easier, this is totally up to you. I'm going to just call in the level list and the inventory right here. You absolutely could pass them in as parameters and then return them as things that you've messed with, but you can actually directly edit them inside your function if you call global. A lot of my Pythonistas who are watching this are probably going to say that's not best practice, and they might be right, but it works. So let's move on. global, we call level and inventory. Now what I want to do is create some coordinates that are basically checking my actual player's image. So not the pixeled locations that I'm using just to call them. I want to check based on the actual image so that it looks good. What am I colliding with on the right and the left? And then where should my feet and my head be considered to collide? And to do that, I'm going to create a bunch of integers based on the player's X and Y positions, and I'm going to use those to check against the levels list. So for the right coordinate, I'm going to say it's wherever X is plus 60, and then I'm going to floor divide the thing by 100 because we want these to be coordinates in terms of those list coordinates. And you remember our tile size is 100. So this is where I'm kind of making it specific to my game. If you have a different tile size, make sure you update these accordingly. And then for the left coordinate, it's just going to be player X divided by 100. That one actually looks pretty good. It holds pretty true. And then top coordinate, top coordinate and bottom coordinate are going to be based on the player's Y, not the X. So let's go ahead and check this out. And the head really works best at player Y plus 30 because, again, we made it 8 times 14 right now, which is, I think, 112 in terms of Y coordinates. But this may take some guess and check. You can use my values as a starter, but if you have a different character who may have different outside dimensions, you'll see once we set up the collisions, this needs to look good. So this is less about what's happening in a geographical sense or a geometric sense. It's more important about the visual appearance. Like when my feet hit the ground, does it look good? So basically, bottom coordinate is what looks good at about player Y plus 80. So about 80 pixels down from where we started. And the reason I'm moving the top coordinate down about 30 is because I actually think it looks better if your head can kind of come up to a platform. Like in most of the most fun platformers I can remember playing, you can actually jump up through platforms and you just can't go down through platforms. So it's almost like a clambering effect. Like you can jump up into them. All right, and so we need to set up some more things now, which is actually check the 4 tiles that we're colliding with, right? Like what's our top right, top left, bottom right, and bottom left? In theory, because the player isn't more than 1 tile wide and we're not checking over a range of more than 1 tile high, we can just check these 4 tiles and make sure that we're not colliding with those. So it's going to be equal to the level at the top coordinate followed by the right coordinate. So remember, the order this is going to go in is check what row you're in and then check what column you're in. So top coordinate, we're going to have top right, we're going to have bottom right, we're going to have top left, and then we're going to have bottom left. And so change these 2 to bottom, change those 2 to top, and then change these 2 to right, and then these 2 to left. And I see that I called all of these bot, but this one bottom, so I will just come back up here and change it to bot, because you guys are children anyways, and you'll laugh if I leave it as bottom. Okay? So here's what we're going to say. We're going to start by checking the top, and we're just going to say, in general, if the top coordinate is greater than or equal to 0, then I want to check through all of these things. And the reason I'm saying that is because if you happen to jump and you jump north of the board, I'm actually going to let that go. I don't want hitting the ceiling to be like colliding. If you watched the showcase in the beginning, I think it's kind of part of the game to be able to jump off screen knowing that you'll come down somewhere unknown because you might have moved X and Y direction. But if you were checking these coordinates, these level coordinates, with a top coordinate that was off screen, then it's going to throw you an error that says like list index out of range. So basically, that's my spiel for why I have this if bottom coordinate is greater than or equal to 0. Top coordinate is greater than or equal to 0. So what we'll say is if, and then if my top right or my top left is between 0 and 4, okay? So if you remember, that is rock, that is platform, and then that is also like surface rock. So if you collide with one of those in your top right or your bottom right, and I need my greater than 0 and less than 4s in here as well, then what are we going to say in here? Collide is equal to 1. That means that you've collided in the right direction. And then I'll say elif, and I'm going to copy both of these rungs. Control C, slap them in here. Shouldn't slap anything. All right. Elif, and then I'm going to change these to top left and bottom left. So basically saying collide is -1 because I'm using 1 so far for right and then -1 for left. And then we'll say else collide is equal to 0. But now we need to say, okay, what about the scenario where the top has gone off screen but the feet haven't? Because you could still collide with something left or right if with just your feet, right? So we'll then check based on the bottom coordinate. So we'll say elif the bottom coordinate is positive, but the top is not. And we can actually keep this same code, but we're going to get rid of the stuff that references the top right and the top left. I know how confusing this might be, but you have to think about it in terms of these coordinates are like a floating box around your player that moves as you move, and it's constantly checking what 4 tiles are you colliding with, okay? So basically this first part is checking if we're colliding to the left or to the right, assuming you're fully on the screen. The next is what if you've jumped off the screen and your head is gone, but your feet are still on the board? Okay, so those are basically the 2 ways that you could collide with stuff in the left or right direction. And now, just to be thorough, let's think about the scenario where you're completely off the screen. Since you're not able to put obstacles off the screen, we'll just say collide is always equal to 0 while you're up there. All right, so this is a pretty cool way of just checking, am I colliding with something on the left or with something on the right? But now we want to check and see if we should be collecting keys and if we are colliding with doorways, right? So let's go ahead and check. And this is a bit tedious, but it's going to look pretty good. So we'll say if, and now we're going to check all of our coordinates and see if we collide with a key. So if 6 is less than or equal to top left is less than or equal to 9. This means if my top left shoulder is hitting a key, then we want to say if not inventory at, and then top left -6. So think back to the very beginning. This is saying in the list for the level, this index value is 6, meaning the blue key, right? But inventory is just a list of 0, 1, 2, and 3, but the blue key is index 0. So basically the value that I've hit is somewhere between 6 and 9. If my inventory at that value -6 has not yet been collected, meaning, and these shouldn't be parentheses, they should be square brackets. Excuse me. So I'm saying if I haven't yet collected that, then what I'm going to do is just say inventory at top left -6 is equal to true. And that's how I'll collect it. And what's really cool is you don't have to do anything like setting this variable on the board equal to false anymore, because the way we wrote our draw board function, it's going to automatically disappear. So this is going to handle colliding with any key with your top left shoulder. And now we will do the same for all the others. So top right, and you bet you could set up a for loop so you don't have to type this code out 4 times, but here we are. And bottom left and bottom right. Bottom left. Bottom left. Bottom left. and bottom right, bottom right, bottom right. Okay. And so this is pretty cool. It's going to handle colliding with keys, collecting the keys, and then the keys will automatically no longer be drawn on the screen once you collect stuff, and your inventory will automatically update to say true. And we'll make all these elifs just because that's kind of more accurate if otherwise, right? Because the player is not more than 1 square wide, as we've discussed. So if my top left shoulder is colliding with a key, my top right shoulder won't be. You don't have to make these elifs, but I am going to. All right. So let's go to the final thing that we're checking for collisions with. We've got the tiles, and we've got the key cards. So let's add checking for collision with doorways. And so this is going to seem fairly similar to this, and it really is. But instead of 6 through 9 for everything, it's going to be 10 through 13. So let me just copy this down. Okay, 10 through 13 is going to mean I'm colliding with a doorway. But then what's important is still checking there we go. What's going to be pretty important, I'll just get all these updated, is still checking the inventory, because there's no reason to register it as, yes, I'm colliding with a door if you don't have the key for it. There's really no benefit to you of finding a door if you don't have the key for it yet. It might as well be a wall. But so what I will say instead of -6 now is -10. And then instead of making this inventory at top left -6 true, -10 true, we're going to update this list that we made of door collides. So door _ collides, and we will keep the order the same, blue, green, red, yellow. And so we will basically say, if I collide with a doorway and I do have it in my inventory, so we need to get rid of these knots as well. So if I do have it in my inventory, then I want to return that, yes, I'm colliding with the blue door and I should be able to go through it. We'll use that once we get to the player functionality that's checking to enter portals, okay? So bottom left -10, bottom right -10, -10, everything -10, -10, and then get rid of these not inventories. It's just if inventory, if inventory, if inventory, and then door collides instead of inventory gets updated now. All right, so this is pretty cool. And just to do a little bit of play testing, if our left and right is actually working, let's come up to that one row that I made that we're going to say is play testing, and I'm going to put a blue key at 6 here, and then I'm going to put a blue portal here at just a few over. And then so that we can test a few things at the same time, I'm going to go ahead and put a block down over here so that we should be able to walk into it and check that we actually walk right into it, okay? So let's boot this up. And now you can see just by changing a few values, oh, and that's interesting. Did I leave one? No, they're all false. So let's see. Oh, no, yes, I left the blue key as true in here. So make sure you reset your inventory back to all false before testing. Okay, so we've got this blue key card, meaning we haven't collected it yet. The blue portal is locked, and I should walk into this rock. So let me see, can I collect the key card? I can, and then the portal goes away. So once we set up the mechanism for going through doors, that worked really well. Now let's see if this stops me from moving right. And it does not. Oh, right, because we're not doing anything with checking whether or not we're colliding, but we can assume that the variable probably is working based on the fact that those other collisions worked. So we need to come down and we need to modify our walking, where we check to see if we're on the screen, and just add another condition, basically to say, am I colliding in the direction I'm trying to go? All right. So what we have down here is we're saying, okay, if we're trying to go left and we're on screen, which means it should be allowed, but then we also want to say, and colliding does not equal -1, which means we're colliding to the left. And then likewise, when we're trying to go right, we need to make sure and colliding does not equal 1, meaning we're not colliding when we go to the right. So now if I load it up, let's see, I'll still collect the card, which is sweet, walk through the portal, and bam, I get stuck at this rock, okay, which is awesome. And I'm going to, just so we can test a few different platforms, let's try what are all the ones we're not supposed to be able to walk into. It's like the platform, the rock, and the underground rock, right? So I'll make this 1. I'll actually start him here, and then I'll make this a 2, which I think is a platform. All right, so, oh no, I want a 3. I already know 2 works, so I think 3 is the platform. There we go. So now, my little initial testing here. Key card works, the lock drawing works. I can't walk into solid rock. I can't walk into the platform rock. Let's see, I can't walk sideways into a floating platform, okay? So the left and right collision is working great. Now we need to set up some up and down collision. And the reason we haven't set any up and down collision up yet is because we haven't put any Y movement in yet. We haven't incorporated gravity or jumping yet, which is a huge part of a platformer. So even though it looks like he's walking nicely on a surface, he's not walking on a surface at all. We're not registering feet in any way. So to do that, we're going to set up a new variable that a new function that we're going to call check verticals. All right, so let's come down underneath where we handle X direction and check for collision with tiles. And let's do a new section, which we'll basically call jumping code and vertical checks. Okay, and in here we're basically going to say if we are in the air, which is a new variable we're going to have to make, then what we want to do is just say, well, the Y needs to change by an amount that we'll make, and we'll define a gravity variable, not anti-gravity. Gravity, that's neat. And then we are also going to want to change player Y by the Y change. Okay, so this may seem like some extra steps, but the reason for this is we want the Y change to get more and more negative the more time you're in the air. If you think about how gravity works, acceleration is change over time. So we're saying player Y needs to decrease by a variable that gets larger the longer you're in air. And then we will say if not in air, then Y change should be set equal to 0, right? We're not going to change gravity, and we're not going to change our actual Y position once we detect we're not in air. All we're going to do is we're going to change how much we change by. All right? And then what we want to do is we want to say that this in air variable is actually going to be based on checking our vertical positions. Check verticals. It's going to be fairly similar to what we just did for checking collisions in the X direction. Now we'll be checking for collisions in the Y direction. And so to start, let's go ahead and make a gravity and a Y change just initial value up here. So let's come up to our game variables and let's make a gravity and let's make a Y change. And now, to be fair, when the game starts up, it might as well be a Y change of 0. There's really no value in starting the game with you already moving downward. And you can play around with the gravity to what you feel is good. I feel like for a space-themed, like moon level of gravity, 0.5 is actually really solid. So now we called this function check verticals. So let's come up above where we did check collisions. And let's make a new function. So check for vertical collision with solid tiles, we'll say. And then define check verticals. Okay? All right, so the check verticals function is actually going to be a little more simple than the checking for X and Y collision, because we don't care so much about if we've touched a door or a key card, because we actually handle top left and top right in that check collision. So this is specifically meant, are you in the air and jumping or are you not? So to do that, I'm just going to, again, actually I will pass in the player's Y position in here, check verticals, just to show you. So player Y, just like that. check verticals doesn't return anything. Right. And we need to remember that this is the function that's telling us whether or not we are falling. So inside the function, I'll call it falling. Outside the function, we'll call it in air. And then just to start here, I'll assume that falling is false. Doesn't really matter what you assume it is initially, just to call it the first time. You just want to make sure it's defined. All right. So now I'm going to actually base the, I'm going to base the, are you on a platform or are you in the air based on the player's midpoint on the X position. So I will say center coord is going to be equal to, and then I'm going to make this an integer based off of the player's X position plus 30. And then I'm going to floor divide it by 100. So actually I need to make sure this whole thing is in the integer, even though floor division will always give you an integer. And then I'm going to define bottom coord in here, just like I did with the previous collisions, and say that that will be an integer value based on the player's Y position, which I guess we're passing in, but we actually don't need to. Player's Y position plus 110, so more or less where the feet are. Because if you think about, am I in the air or am I not, really just want to know where my feet are. So we will say that's 110 from the coordinate we give the Y. And then we're going to say if player Y plus 110 is greater than 0. And that just means that we are, this should be plus 110. That just means we're on the screen, which means we can check through the levels list for like a legit value. We don't want to check for list index out of range. So then we say if 0 is less than our level list at, and then the position we need to check for is bottom coordinate, center coordinate. Okay? And basically, if that is greater than 0 and less than 4, right? Those are the solid walkable tiles in the game. Then we want to say that falling is equal to false. And then we will say otherwise falling is equal to true, because it means my feet aren't colliding with anything solid. But then we'll also say else, otherwise. That means that falling is equal to true, because that means that even my feet are so high that I'm off the screen and there's not even any point in checking what tile of the level I'm on. I am falling. So then what we'll say is down here at the bottom, we can actually update this. So here's maybe a benefit of return falling. We'll also return Y position. And we'll say, okay, if we've gotten through this whole thing and we aren't falling, that means that we are colliding with something. If we're colliding with something, we want to make sure that we're at the very top of that tile. So we'll come down here and we'll say if not falling. So we've gone through this whole code and we've seen that we aren't falling. And yeah, there's actually no reason to have it defined up there because we cover every scenario here. So if we're not falling, then we want this Y position to be equal to the bottom coordinate minus 1 times 100, and then just scoot it up a little bit, so minus 10. So we're basically saying, because you've got to think about how we're updating the Y position using gravity. If you have fallen to where you've hit a tile, maybe you were falling at 3 pixels per click per frame. Maybe you were falling at 9 pixels per frame. It depends how aggressively you made your gravity, and it depends how high you make your initial jump. So we want to say once you've collided with something, collide with the top of it. And so this is just a good way of controlling how far you fall once you've hit something. All right, which means we need to come down to where we call it, and we need to say in air, comma, player Y is equal to checking the verticals. Now this is cool. Jumping code. No, I'm not missing an issue. All right. Sometimes the squiggly lines make me question myself. All right. Now this shouldn't do anything. Oh, I've got something backwards. I think I've got something adding when it should be subtracting. So let's see. We have y change minus equals gravity, and then we have player y plus equals y change. I think it needs to be player y minus equals y change, because moving down is actually increasing the value. So there you go. I think the easiest way to test this is probably build the jump command. So let's go ahead and figure out what to do with key down when we press the space bar. All right, so we already have the framework for key down built. And now let's say if event.key is equal to PyGame.k underscore space and not in air, right? We're not riding a jetpack. This isn't Flappy Bird. We don't have the ability to jump if we're already in the air. But if we weren't in the air and we press space, well, we are in the air now. So we set that equal to y change, or we set that equal to true. And then I want to set this y change as kind of just a one-shot equal to a variable that we'll call jump height. And that'll be the easiest way to control how high we jump. So we just come up into our game variables up top, and we make a new variable called jump height, and let's figure out what a good height to set that to initially is. Now this is space themed, so I want to be able to jump pretty high and come down fairly slow, kind of like you're moonwalking. I felt like in initial testing a jump height of 14 was pretty good. Let's go ahead and check that out. Oop, I hit debug, not play. Here we go. Let's go ahead. If I press space, nothing happens. Groovy. So let's go ahead and figure out why my space bar isn't getting us moving. So I want to say that maybe what we need to try and do is check our verticals after we change position here. So let's go ahead and say if in air. Let's see this. Oh, what's our issue? In air is not defined. Yeah, well, I thought it was. I thought I set it equal to false right in the beginning. In air equals false. Just doing a little troubleshooting. Never hurt anybody. There we go. So yeah, I think the problem was when you press space, you're only in the air for one scan, but then we also have in air written to in our check verticals collision. So we were never moving the player far enough north that it was no longer colliding with the platform. So I would press the space bar, but then before we ever did the code that moved the player, we would overwrite our setting in air to true, and it would see we were still standing still. So just by moving this function down below our check for whether or not we're in the air, we were able to fix our jumping code. And now let's go ahead and test play just a little bit. I should be able to move left and right and jump, and these platforms that I register as solid, I should land on. And you can see that's actually pretty sweet how fast we've gotten that working. So I can land on a platform, I can land on a solid square, I can stop moving in the air and my player looks idle. So this game, we've actually created a lot of the basic functionality already, and I think this looks really cool. All right, so I think now we're at a point where we have to talk about the way that I designed this game to actually use levels and the benefit of having your levels in a separate Python file. So I'm going to open up my levels and we're going to start talking about why I have it this way. And just to start, if you didn't download the code from GitHub, but you want to follow on with this tutorial, I'm not going to show you the exact way that I sat through and I typed out the full numbers for each of these first levels. Just know that you can pause it here and then here, and you can copy down the 4 phases, main, red, green, and blue, and then you can put those 4 phases into this one item that I call level 0, which is just a list of the 4 phases. And then you can put level 0 as the only item in levels in this levels list, and that'll get you to a point where you can follow along with what we're about to do. Because then when you use the level editor, which again I talked about in the intro, I'm not going to show you how to build a level editor in this video. I did a full tutorial on how to build a level editor. It was the previous video on this channel, so check that out if you need the full explanation. But it makes it really easy to design levels and get them in this format, so you can just copy them into this levels.py function, levels.py file. And then what we're going to do to use those levels is we're going to import right beneath PyGame. In the very beginning, we're going to import levels. Okay, so we're going to import levels, and then from that, we're going to come down to our level, and we're going to say we actually, instead of this, we want level to be equal to levels dot, and then no, not levels dot. It's just going to be levels, and then active level, and then active phase. So we need to create two new variables that are going to tell us what level and what phase we're currently on. Active phase. Okay, so to start, active level is going to be equal to 0, and active phase is going to be equal to 3. And the reason for that is the way I designed my level 0, my first level that I put in there, is actually you start out on a screen where you can see the gold portal, but you don't have the gold key yet. So you got to go and get other keys. This is where game design comes into it a little bit, and if you don't want to get into any game design on your own, just use my levels and follow along. But basically, we're saying, okay, go into my levels .py file and grab my levels list. And then at active level 0 and 3, that's where I'm going to start. Okay? So now if I boot this up, what you should see, module is not subscriptable. Yeah, okay. That's because I need to say from levels import everything, and then we can just say level equals levels at active level, active phase. Sorry, this is technically a list of a list of a list of lists, and so this is like 4 nested lists. So now we're getting there. You don't need both of these import statements is what I'm trying to say. They're importing the same thing. But that was a lot of confusion. What we're doing now is I'm storing all of my level data, which is just a lot of confusing arrays. It's actually 212 lines of code to have 6 levels total. And I've divided them up into these phases where you get specific keys in that phase. So this is where your level design comes in, and you can play around with the level editor. But you see on this initial phase that boots up, you're on the gold phase. You can get the red key card and get through the red portal, but you can't get the gold key card yet. But just using the levels that the commands that we've set up, the player controls that we've set up, you can load in any level and start interacting with it in this way. So you can jump on platforms, you can make it over these different ridges, but you can't walk to the left and to the right through stuff. So then what you'll see, we haven't put anything in for collision with acid yet. So we'll do that when we introduce the lives dynamic, but I don't want to gum it up too much and make it too confusing just yet. But now you can see you can also collect the red key card, and now you can go through the red portal. So that's pretty cool. What I want to do before I introduce the teleporting method is I want to draw the inventory on the bottom of the screen and show why it's best in these levels, at least the way I have it set up. It's best to just constantly leave the bottom 2 rows as acid, non-key card stuff, because I want there to be a pretty significant inventory loadout on the bottom of the screen that kind of tells you what's going on. So we're going to do that, we're going to come down into our main game loop, pretty much right under where we draw the player. So main game loop, draw player. And we're going to put another one in here, and we're going to call it draw inventory. Just like this. And we don't really need to pass anything into draw inventory. We're going to take care of everything we need in there inside the function. So let's come up kind of where we've been doing our functions, and we're going to define draw inventory, okay? So let's come up above all our other functions, and we're going to say draw inventory and instructions and scoring on bottom of screen. All right. Oop, well, I can't spell, but that's all right. Define, draw, inventory. Now we're going to put this in here, inventory. And in here, we're going to start and define a font. I usually do this in the very beginning, but the reason I'm doing it now is because almost every time I use text in this game, it's going to be a different font size. So I'm just going to redefine my fonts every time I need it. So pygame.font, and then this font file I actually have stored in my assets folder. It's this sci-fi 2 or sci-fi TTF, whatever you want to use. I actually really like the sci-fi TTF because it kind of looks like Star Wars font. I got it for free from a website called dafont.com, DAFONT.com. It said completely free to use, so I am not stealing any copyright material. To be clear, in case anyone from YouTube asks, all right? So now, font equals pygame.font.font. I'm going to set up a quick little colors library, and the colors are going to look, colors list, and it's going to look pretty familiar because it's blue, it's green, it's red, and then it's, you guessed it, yellow. Just because I'm going to draw some rectangles for storing key cards once they've been collected, and I want to have those colors readily accessible, okay? So now let's draw some static rectangles to just kind of look like a box that you would put stuff in. So like an inventory screen. So to start, let's put a rectangle on the screen. Let's make it black. And to give it some dimensions, we're going to just scoot it from the right edge a little bit, 5 pixels out, and then move it off of the bottom of the screen by 120. And then we are going to make it as wide as the screen, minus 10 total. So this is basically giving us a 5 pixel gap on either side. And then we're going to make it 110, which is going to give us, again, actually that'll give us a 10 pixel gap on the bottom, which is going to look pretty good overall. All right, and we're going to make this a solid rectangle, but we're going to make it a rounded rectangle like that, okay? And now if I just boot this up, you should see the overall shape. So we're going to use this bottom kind of as the loadout. That's going to tell you like what's going on in the game, what task you currently have, and also what cards you've collected. So we're going to start adding things inside of this box. This next bit of code is going to be sort of design and style, but that's really important when you're creating like a full-fledged, fun to play and share game. So then I'm going to put this cool kind of sci-fi looking purple border over top of that, but I'm only going to make it width of 3, so not solid. So it's just going to be this thin purple border around the outside. And now what I'm going to start doing is I'm going to start taking kind of similar rectangles, but I'm going to make them white, and I'm going to start dividing that section up into smaller sections. So like we're going to have one section that's just what key cards do I have? It's like the 4 key cards, have I collected them or not? Then we'll do a score section, then we'll do an instruction section, and then we'll throw the logo in at the end. Okay, so for this first one, we're going to just kind of make it the same dimensions, but like 3 pixels inside of what the larger one was. And then instead of being super wide, we're just going to make it wide enough to put like 4 boxes in. So it's only going to be 104 tall, and then we'll make them not solid like the purple one. So just to show you what these 2 rectangles look like now, I've got this cool purple outline around my whole black rectangle, and I've got this white section that I'm going to check the 4 key cards in that area. So let's kind of keep adding the white rectangles so that we can eventually fill this in with the 4 sections that we're going to have. All right, so we're going to have a total of 4 rectangles. And this first one was, it started at 8 and it was 340 wide, so it's going to go 348. But the height is going to be the same, so the Y starting position. And now if you want to put different stuff in here than I put in, you just are going to need to play with your widths a little bit and your starting positions a little bit. Because basically the 2 widest ones are going to be the scoring, which is going to be about 530 wide. And then the second widest one is going to be instructions text, which is going to be 720. The logo is not going to take all that much space, so it won't even be 200 wide. But you just basically want these rectangles to be butted up against the one that they are right next to. So mine go 8, 348, 880, and 1600, and they need to be this wide. All right, so if I run this now, you see I get this inventory split up into 4 sections, which looks really good. So let's keep going and start putting stuff inside of these sections, all right? So let's start with the actual keycard inventory. And I'm going to make this font italic because that looks cool, and I get to show you guys how to set the font that you define up here, set it equal to italic just by saying font.italic equals true. And now let's define the inventory text. So inventory underscore text is equal to font.render. And then I find this looks good on a lot of game stuff. Putting spaces in between every character just makes it look kind of cool and spread out. So if you have the space for it, I recommend you try that spacing sometimes on your games. If you put them all smushed together, it still looks fine, but we have the space for it. So we're just going to put this inventory text right in that first box. So screen.blit, the inventory text, and then comma, and then we'll put it at x14 and then height minus 117. So that should put us right at the top of that first box. Let's go ahead and check out how that looks. So here's your first chance to see that font. I think it looks pretty cool, kind of sci-fi, but also easy to read. And now let's go ahead and put the colors. Let's put the colorful boxes for the inventory on the screen, okay? And so I will just say for I in range 4, because I know that there's 4 key cards I'm checking for total, pygame.draw.rect, and then we'll put it on the screen. We will make the colors at I, which is why it's nice to have that list of colors that we made before. And then for their positions, we're just going to start from 10, because that's kind of the first one we want, and then do 80 times I, which we know 4 will fit because we made it 340 wide. So we can make it 80 times 4 is 320 and still have a little bit of a border on either side. And then for the height, this is easy. It doesn't need to change for all of them. We'll just say height minus 88. And then make these squares 70 by 70, okay? And then this is just a style preference thing, but I do like rounded rectangles. I think the sharp corners look a little more old-fashioned. Rounded looks a little bit more cool and futuristic, I guess. But then we're going to check if our inventory at position I is true or not. And if it is, then we need to rescale the keys because the key images were too big initially to fit inside these little boxes that we're making now. So I'm going to make this new image that's scaled key. And it's going to be that pygame.transform.scale that we did before, pygame.transform.scale, keys at I, so whatever color we are drawing on, and then we're going to scale this down to 40 by 70 so it can fit in our 70 by 70 rectangle kind of nicely. And then screen.blit the scaled key onto the screen, so scaled key. And we want to put that at a position that's a little bit to the right of where the actual box starts. So it's going to be 25 plus 80 times Q. I don't know why I put a comma. Everyone makes mistakes. All right, 25 plus 80 times Q. And then height minus 88, just like that. And so now, hopefully, when I load this in, it does look like I've made one error. We'll see what it is. Nope, that looks okay. So now I'm hoping when I go and I get that red key, what you'll see is it'll delete from the screen, but it'll also update my inventory. And name Q is not defined. Yeah, because I said 80 times Q, it needs to be 80 times I. There's the error. All right, let's try this one more time. Hopefully that fixed it. And when I hit this red key, it's going to update my inventory. There we go. So now I have a little red key card in my inventory, which looks great, and the door is unlocked, and it's no longer on the screen. So that's working really well. The rest of the stuff in the inventory is really just some static stuff that we got to put on there. So I do want to go through all of it with you guys, but I think what would be more fun right now is if we create the teleporting, and then we'll come back and we'll finish the inventory stuff when we are ready to do scoring and set up like timed stuff. And we'll also display what level you're on and what phase you're in and tell you how to play the game all in that space. But we'll do it later because this draw inventory is not all that exciting and it takes a really long time to do it all. So let's shift gears a little bit and take a look at teleporting, okay? Which sounds pretty cool and it sounds a little intimidating, but all it really is when you're colliding with a door that you have the key for, which we already check and see if you're doing that or not. When you're colliding with the door that you have the key for and you press enter, we're going to send you to a new level or phase, which also has that portal on it. So this is something you need to know as a game designer, is you need to have 2 portals of each color in your game, because what you want is once you have the key for a portal and you enter it, it takes you to a new map that you have another objective on, either another portal to go through or another key card to collect. So for this, we're going to come down and we're going to go to our key down code, and we're going to check for a new key, which is going to be PyGame.keyReturn. And actually, we're going to do this in the key up because it's better practice to just, when you release enter, to teleport. So we'll do it this way. If event.key is equal to PyGame.k_return, and it makes more sense that it would say enter, but a lot of older keyboards and desktop keyboards, that button said return a lot more than it said enter. So PyGame's just standard is they call it PyGame.k_return. Okay. But then what we say is for I in range length door collisions. All right. And now we're checking to see if we are colliding with a door. If door collisions I, which means, all right, you've pressed enter and the door collisions at I is true. So basically this is saying for I in range length door collisions. Okay, if you're colliding with the blue door, then this would say if blue door collision is true, otherwise green door, red door, yellow door. All right. So if you're colliding with that door, let's start with phases other than the gold door. Because remember, I want to use the gold door as what moves you to the next level. We'll use the other doors as teleports between that level. So we'll say if I does not equal 3, because I decided 3 is the gold phase. Well, then we're going to set the active phase and the player's coordinates. So player coords equal to, and we're going to create a function called teleport. And we're going to pass in whatever I is and whatever the currently active phase is. Okay. And then we're going to need to create some more stuff based on this later. But basically the reason we're getting player coords in the active phase out of that is because we want to know what phase we're teleporting to and where we need to move the player to in that. So let's go ahead and create the teleport function. We'll come back up where we're defining functions, and we'll say create teleport when going through portals. Teleport when going through portals, and we'll define teleport right here, and we need to remember to return phase and coords. And what we want to pass in, you'd think I'd remember because I just made it a second ago, index and current phase. So index and current phase. Alrighty. Now, the teleporting is not going to be all that difficult because what we're going to do is we're basically going to check for what phase in my current level, other than the one I'm in, has the same color, the same basic index value that I just teleported through, and where is that portal, because that's where I need to move. So basically, what we're going to say is initially phase, we'll just set it equal to current phase, just so it's easier to use. And then coords, by default, we'll just say 0, 0 and modify them inside of this just to sort of initially call them. Now what we'll say is for I in range length of levels at active level. Okay, so this is checking through each phase in our active level. And then for I in range, and then what we say is for J in range length. And now this is where it starts to get really confusing because like I said, levels is a list of levels, but each level has 4 phases. Each phase is an array. So if that gets confusing, I totally get it. You're just going to have to talk to your therapist about it. All right, so now we're saying for I in range active level at I. So we're actively checking through each phase in here. And then for J in range of each phase, what we're going to say is if index plus 10, which is how we change our index, which is 0, 1, 2, or 3 for what door we just went through, to the actual raw numerical value of that colored portal as we define it in the level. So if that portal is in levels active level I, J, so let's copy this, levels active level I, Control C, and then J, where we're checking through each row inside of that phase. And we need to also make sure that this is not the phase we're actively in. So and I not equal to index, right? Because we don't want to just teleport to where we are and think that we found it. All right. So and I is not equal to index, then we want y pause to be equal to p, and then x pause is equal to levels active level. Man, I wish I could spell. Sorry, not P, I, J. Jeez, Jiminy Christmas. There we go. And X pause is going to be equal to active level inside level at position I, which these are, again, they're just X, Y coordinates. I, J dot index of index plus 10. Okay? So let me just put these in a coords tuple, and then I will talk to you about how we got those one more time. All right, so let's see here. And then what we need to do is set phase equal to the phase that we just found, which is I. All right, so we are setting, bam. Yep. All right, let's talk about this really quickly. We are saying for I in range length of the active level. This is saying for every phase in active level. So the blue phase, the green phase, the red phase, and the gold phase. Then check each individual row inside of each phase. If the portal that we're looking for is in that row and that phase is not the phase we're currently at, then the Y position is whatever row inside the phase that is related to the portal, and then the X position is the column that portal occurs at inside of that phase. So it may seem confusing, but that is because levels is a list of each separate level which has 4 phases in it. Each phase is an array of 18 by 9. So that's as simple as I can explain it. I know it's still complicated, but I hope if you sit and think through this, it starts to make sense to you. Then let's put the coordinates in an X and Y position tuple, just like we're used to. And let's set the phase equal to whatever phase we just found it in. All right. So hopefully this is actually going to work. I think now if we come down to our event handling and we look at K return, what we're saying is if I've collided with a door, and if it's any door other than the gold door, then what you should do is you should figure out what phase that needs to become, and then you should also figure out where my player coordinates need to be. And what we'll do is we'll say player X is equal to, and it's going to be just like we did in the beginning, player coords at, and this time we moved X into 0 because I'm a fiendish little boy. And then this time Y is player coords 1 times 100 minus, so hopefully this looks familiar because it's what we did in the beginning when we had initial coordinates based off of where 5 is in the level, where the player spawn is. All right. And then what we need to do is we need to set level equal to levels active level. And the nice thing is active level hasn't changed because we haven't handled going through the gold portal yet. All right. So active level and then active phase. And then we can reset the init X and init Y equal to player X and player Y. And again, when we handle colliding with the acid, you'll be really glad you already have these initial values set up, because all we'll do is we'll revert the player to these initial positions once they collide with acid. So what we'll also want to do is just say, on the off chance I was falling through the air when I teleported, this will reset you to not falling anymore. So Y change will be equal to 0. And then what we'll say is once we've gone through the gold portal, so that's going to be your else, then we want to say as long as active level is less than the length of levels minus 1, meaning we haven't gotten to the final level yet, then we'll say active level plus equal 1. Okay? And then that's going to be pretty easy. Later on, we'll also handle like winning in this position, but we don't have to do that just yet. And now we're going to set level equal to levels at active level now that we've updated it. And then active phase. And the thing is, you can do it this way if you know that you're always putting the gold portal as phase 3, so you're always going through it, and then you'll still be on 3 when you load in. Otherwise, you might want to put active phase equal to 3 right here, just to make sure. If you're the sort of person who could forget and put a gold portal on like the blue phase of a level, it's not a bad idea to reset it to the main phase when you come to a new level. All right, so now that we're resetting the level, we have to do the same kind of deal that we just did with resetting the position and the level and the player X and player Y and all that. But what's a little trickier here, so I'll copy all those because those don't have to change. But if you remember, when we load in a new level, we also want to clear out the inventory. So inventory is equal to false, 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 because every level has its own set of keys to collect. And then we need to find out where the 5 is again. So for underscore in range length of level. And this is the exact same for loop we did in the beginning. We're just checking if 5 is in level at underscore. So we're basically going through every row of the level and we're checking to see if the start position is there. And if it is, then the start position is going to be equal to 2 coordinates. The first is underscore, and then the second is just going to be level underscore, and then the index, square brackets, come on, Pete, dot index of 5. So again, this is exactly the same as the beginning. We are just saying we've just loaded in a new level, so new player X and Y start position, and put them right here. So we should now, with just what we have here, we should be able to go through portals and get through all of level 1. So let me load in the first level that I created and let's play test this. All right, let's go get the red key. Dun, 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 dun. And let's see. Hopefully, if we set up teleporting right, it moved us, but it doesn't look like it changed phases because it should have taken us to a different phase. So let's go ahead and do a little troubleshooting. You can see it changes the player's X and Y slightly, but it's not moving us to a different phase. So, all right, let's check out what we're doing with teleporting and what we might be doing wrong. Active phase is equal to current phase, coords initially 0, 0. And then we're saying for I in levels, active phase, and I is not equal to, so this is saying I is not equal to index, but what I think we want to say is I is not equal to current phase. There's difference between what door you're colliding with and what phase you're on, obviously, because this is the gold phase, but we're colliding with the red door. So now let's see. It should take us, bam, there we go. So this is now the red phase where you go through the red portal, collect the green key card, go through the green portal. This should take us to getting the blue key card, going through the blue portal. And you can see I used the same actual basic level outline for every phase on level 1 because I was playtesting when I built this. And then on the blue phase, all we do is we go get the yellow key card, and then we got to go back through all those portals because the gold was right where we started. So we go back through blue, we go back through green, we go back through red. Can I get there? Bam. And then we got to go through gold. Now, this is a big test. It should take us to the second level that I built, and it should clear out the inventory. Bam. And it drops me, and I'm dying. Okay. So I actually think that the finding the new start position did not work properly there. So let's take a look at that because I believe level 2, I have the start position. So level 1, main. Yeah, I have the start position down in the bottom left. So something we wrote is just a little bit off for finding out where to start. So level equals active level, and then for underscore in range, length of level. Let's see. Yeah, this is because we put this in start pause now. So this is where copying it from the very beginning would have saved me rather than copying it from our teleport code, because actually this, if you remember, we got these ones a little backwards, 1 and then 0. So now, I guess I'm not going to make you guys run through that whole thing. I'm pretty confident that was the problem. You can play test on your own if you're having the same error. But now we've got the teleporting working and we've got the level tracking working, which is really cool. So what we need to do is we need to update the rest of the draw inventory because we've got to give the player more information on what's going on, what the objective is, and where you're going next. So let's finish this draw inventory function, okay? And I'm going to move pretty quick because this is a lot of text and a lot of just instructions and various colors that need to go on the screen. So I'm going to try to keep it moving because I know this can get a little tedious. Again, if you have any questions about the specifics that you see on this in this specific part while I'm trying to move a little faster, just let me know. All right, so I'm going to redefine font because I want it to be a little bit larger text now. I want this to be, I think 32 is what I found looked pretty good. Make sure it's inside so it's part of the function. And then font 32, and I'm going to start by saying level text is just equal to font.render, and I'm going to make a f string, which is a formatted string so that I can combine strings and variables. And it's just going to say level. And then I'm going to say active level. But the thing is, active level starts at 0, and just your casual player is going to be a little confused if they see they're on level 0. So I'm just going to always have this display level +1. So if you've made level 0 through 5, they're going to play level 1 through 6 according to the screen. Makes absolutely no difference to the gameplay. It's a little more standard. You start on level 1. And then I'm going to make the text white. And then I'm going to put that on the screen, screen.blit level text. And we're going to put that at 354. And then we are going to put it at height -119. So that's pretty close to the top there. And I'm going to copy this because we're putting a lot of stuff on the screen now. We're also going to put phase text onto the screen. So we will say phase text. And actually, let's make a list here. Phase strings are equal to, and this will be just kind of easier to use, blue, green, red, and you guessed it, gold. Okay? So those are our phase strings. Now we're going to phase.render, or phase text. We're going to do font.render just like we did with the level, and we will say phase, and instead of just displaying a number, what we'll do is we will say phase strings of active phase. Okay, so this is kind of cool. It's going to say the word blue, green, red, or gold instead of just 0, 1, 2, and 3, because those don't really mean anything to a player. And now we can actually make this even cooler by, instead of making it white, just say it'll also be the color of the active phase. So this way it'll say blue and the text will be blue. It'll say green and the text will be green. So this is just a cool kind of way of making the phase display a little bit cooler. All right. And then we will blit it. So we're going to put it at the same X position, but we're going to move it down to height minus 89. And now let's do one more display lives text, which it's okay that we haven't really incorporated death yet into our game because we want it to be easy to test. But we do want the same kind of display. So we want an F string that says lives, and then we will pass in how many lives we have left. And so obviously you're probably ahead of me. We need to go and make the lives variable, but I want that text to be green. So I'll come up in my game variables, and I'm just going to start the game with 5 lives. When we collide with the acid, that'll lose a life. If you feel like the game's too easy or too hard, you can take away or give more lives to maybe give the player a chance. But anyways, I had to create that so that we can display the lives text and then blit it onto the screen. All right, so let's take a look if all 3 of those look good. Phase gold. Now, the test is I'm just going to pop in through the red portal, and I'm going to see if the phase updates to red. So, pop, pop, pop. Here we go. And there we go. Now we're in the red phase. If I go and I get this key card and then I enter the green portal, we're in the green phase. Bam. And final test, we should enter the blue phase. You can also kind of see now my text really is like ripping off the Star Wars text. But again, I didn't make it, and I did not infringe any copyrights getting it. So, alrighty. All right. So I'm saying that's good enough. Even though I could play this all day, it's a ton of fun. Now, let's incorporate some of the stuff over on the right. So we will basically say if enter message is true, and we're going to use, we're going to sort of check for collisions with the doors to set this variable enter message later. But basically, I want the instructions area, that third block, I want that to read one of 2 things. So I either want it to be collect keys and enter the gold portal, or press enter to go through the portal. So let's do the press enter to go through portal first. We're going to redefine the font again because now we have a different font size. And so it's going to be this same deal, but this one I want to be bigger, and I want it to be 54. Pop, pop. And I'm going to call this enter text 1 and enter text 2, because really the only way to easily get 2 lines of text on your PyGame games is to actually define them as 2 separate strings. So we're going to do font.render like this, and then this one will be press enter 2, and we'll say go through portal on the next line. So we'll say true and then white, and then enter text 2 will be copy this whole bad boy and make it go through portal, and we'll throw an exclamation mark in there to really get them hyped about it. And then screen.blit, enter text 1. And for X and Y position for this one, I just found 900 is a good bit of padding in that third block. And then height minus 135 is pretty close to the top of that box. And then we'll do enter text 2, same X position, and just move it down a little bit from there. And we're actually going to copy that whole thing for the else. All right, so now that's if we're over a portal and we can enter it. We want to tell them press enter to go through portal. Otherwise, they're not on a portal, which means maybe we should tell them what they're supposed to do. Collect keys and get to gold portal, or go through gold portal. We'll say get to gold portal. All right. And then we can leave these named entered text 1 and 2 because they'll never be fighting with each other. It's only one or the other. All right. But so we need to actually define that enter message variable just so that the game knows whether or not it's colliding with a door. So we'll come down in our main game loop because this is a really simple bit of code, and we'll just put it pretty close to the bottom. And we'll say if true in door collisions, just meaning we're currently over a door that we could go through. Then we'll say enter message is equal to true. And then we'll say else enter message is equal to false. And then obviously we don't want this to error out the first time we run. So let's just go ahead and define it right in the beginning with our other game variables and set it equal to false. All right, so that's a simple bit of code, but now what you'll see is if I grab the red key card, so right now it says collect keys and get to gold portal, right? But if I grab the red key card and then I stand over the portal, hopefully this updates. There you go. Press enter to go through portal. And you can use this same sort of format to give instructions in as many different things as you want. So I'm just going to do it that way. So basically, when you're not over a portal that you could actively enter, I remind you of the objective of the game. But when you could enter, it's going to say, well, press enter. So just so you don't have to give as many instructions to the player. Okay, so let's keep working on this inventory because we're almost done. Let's do an easy thing, which is throw our logo in the bottom right. If you make a lot of games, if you do a lot of things for people, then maybe you want to get your logo on the screen and let them know. So what I will do is I'll just come right down here and I'll say screen.blit the logo. And because I put the image in the right scaling initially, all I have to do is send it to the right spot. So width minus 240 and then height minus 140. Okay, so let's go ahead and check out if that looks good when I load this in. All right, LeMaster Tech, bam. Don't forget who gives you killer tutorials. All right, so the last thing we want to put in the inventory menu down here on the bottom initially is going to be your current elapsed time and the total, I think, high score. So let's go ahead and take a look at how we're going to do that. I'm going to start by just in the game variables, I'm going to create a few things. I'm just going to say time equals 0 and high score equals 0 just because I need those variables and I'm not ready to set up timing the game just yet. All right, so let's come back under lives text just to keep things clean because these are all kind of in the same area. And we're going to say time text, and this will be equal to font.render. And this one's pretty easy. It's just going to be a string that says elapsed time and then a colon. Okay, and we'll say true, and then we'll say white, just like that. And then time text 2 is going to be font.render. And then this one we will make an F string. And this will just, for now, we'll just say time seconds, and we'll take a look at making time in terms of seconds later when we actually set up the scoring. But for now, we'll just say true, and then we'll also make that white. And then let's go ahead and actually make the elapsed time text. Let's make this gray so that the white actually pops out a little bit more. And let's put these on the screen. Screen.blit time text. And a good X and Y position for them I found was 600 and then height minus 119. And then for time text 2, screen.blit time text 2. A good position for that one was 600 again. But this one I moved to height minus 89. And that leaves us room for one more row just below that, which is basically best text or high text, whatever you want to call it. Best text equals font.render. And then this should be an F string that says best time, colon, and then in here put high score. Excuse me. And then true. And then for this one, let's make it just a light gray just to differentiate that this isn't really changing. And then screen.blit our best text onto the screen, and let's put it at 600, and then our height minus 59, just a good third row height in the inventory list. And let's go ahead and check that out. Okay, so this inventory is starting to look pretty complete. This game is starting to feel pretty legit. So obviously the last two things that we've really got to get going here are we need to figure out how to set up time tracking to actually figure out how much time is moving by. And then we need to handle winning and losing. And to set up losing, we obviously have to collide with the acid. So we're going to do colliding with the acid. Then we're going to do winning and losing. And then we're going to handle scoring as well as saving and loading to text files to make sure that your score travels with you if you close the program down. So scoring and saving and loading to text files. And then the last thing we'll do is we'll set up music and sound effects. And that's all we'll need to do to create a complete Python PyGame platformer. So we're getting really close, you guys. Let's soldier on. All right, so the next thing we're going to do is check out how to handle colliding with the acid tiles. And you may notice that I'm wearing a different colored shirt, and that is because this is a 2-day tutorial. This thing takes too long to explain to you guys, and I was getting a little beat last night. So we're going to go ahead and continue on with the acid list. Thanks to magic of editing, it'll be like 1 day for you guys. But so anyways, we're going to get this list of all the tiles that are acid when we draw the board. So I'm just going to make this acid list equals draw board level. So we're going to come up to our draw board function here, and we're just going to go to the squares where we draw in acid tiles, and we're going to basically pass in we're going to create an empty list acids that we're going to return. And it's just going to be a list of acids of all the squares that had acid, which is super easy because we already have this if value 4 right here. So in addition to screen.blit, this thing, then what we're going to do is we're going to append acids.append a rectangle so that we can check the rectangle of the space that acid basically occupies, and we're going to put that in a list so that we know when the player collides with any acid square. So basically we're going to append, not the tiles, we're going to append this pygame.rect.rect, which you know from drawing all of our rectangles in the inventory. It just basically requires 4 arguments. First, it requires an X and Y starting position, and then a width, and then a height. And for X and Y starting position, because this is inside of our draw board nested for loops, we can still do the X and Y starting position as J times tile size, and then I times tile size. And then for width, it's just going to be tile size. For width, it's going to be tile size. And then for height, it's going to be integer value of 0.25 times tile size, right? So it's 1/4 of the tile size. Again, you could put a 25 in here, absolutely, if you're using my same dimensions. But let's say you're using a different tile size. Basically, I'm just trying to make it work for you. So this is really cool. No matter what board we're drawing, this is going to give us a list of all the squares that have acid at any time. Which is really useful because now we can just come down into our main game loop and we can basically set up some code checking to see if the player is colliding with any of the squares in the acid. But then one thing we definitely want to do when we load in new levels and new phases, well, we want to make sure we come in here, and anytime we're teleporting, we want to reset our acids list. Did I just call it acid list? No, that's right. Let me see what I called it up here, where we get it from draw. Acid list, singular. Alrighty. So we want to do this when we load in new acids, because the reason for that is we're not changing the X and Y coordinates until the first scan of the next loop. So if you still had acids from your previous board in the position that you spawned into, the first scan would actually cause you to lose a life. I know that from playtesting. Maybe that's not something you would have thought of right away, but yeah, basically when we load in a new level or we load in a new phase, we want to clear that acid list out, and then as the board redraws itself, that acid list will repopulate. Okay? So now that we have handled getting the acids list and getting rid of the acids list, let's go ahead and show what we actually want to do with it. And we'll come down here where we have our true indoor collisions code and just kind of put it there. And we're just going to create a for loop checking through the whole list of acids. So for I in range length of acid list, so this is basically saying however many acid tiles I have, we want to check and see if acid list at I dot, and then because those objects are all PyGame rectangles, they have this built-in checker that we can use, which is collide point, and we're going to check if it collides with a specific point. And the point that I found works pretty well is actually just 30 pixels to the right of the player's X coordinate, which is pretty close to his midpoint, and then the player Y's coordinate plus about 20. So these two are pretty specific to my game and my player because of the scaling I have. You might have to play around with this, but basically what I've found is it looks like the feet hit the acid at about player Y plus 20, player X plus 30. It's a pretty good, pretty fair collision, but you may want to tweak this based on your character and if you're doing it slightly different. But what we're going to do here is we're going to just subtract one from your lives, and then we're going to set the player X equal to the initial X. So this is where setting those initial values up ahead of time makes this reset code really easy, because we always track when we enter a new phase or a new level where we spawned in, and we're assuming the game designer would have had us spawning in at a fairly livable situation. It wouldn't be a very fun game if it was impossible to survive when you spawned in. So basically this is just saying, all right, if I hit the acid when I spawn in, I should spawn back at the beginning. So let's go ahead and boot that up. That should work now. If I just jump in this acid pit right here, bam, and I lose a life. You can see down here lives went down to 4, and I went back to my spawn. Now what's cool, if this works for everything, if our initializing works, then when I go through this red portal, my new initial position is right here. So if I fall in the acid, I should go back to the red portal, and I do. So there we go. We've got that working. That was a really easy thing to add because of how much foresight we put into setting up the acid list and parameters ahead of time. All right. So the next thing I think we want to do is just kind of show if you win or if you lose. And if you win or lose, let's do some, let's make like a pop-up that says you won or you lost. And basically we're just going to handle like giving them the ability to reset. Okay. So jumping code. Let's come up in kind of higher in the main game loop and just say if we are winning or losing, then we're going to print an end screen. So we're going to make two new, all right, after we draw everything else, we're going to make two new variables that are going to be win, and then we are going to make a new function that's going to be print end screen, and we'll have an end screen if we've won, and we'll have an end screen if we've lost. So we're going to use basically this same kind of code, print end screen, for win and lose, but then we'll say elif lose, print end screen lose. So this way, we're going to make two new Boolean variables, win and lose, and just use those to track if we've won and if we've lost. Right when you boot the game up, they'll obviously both be false. So we'll come into our game variables and we'll say win equals false, lose equals false. And now we'll say once you've obviously, when you get to the gold portal and you've done all of the levels in your level list, that's the way that you win. And then if you run out of lives, that's the way that you lose. So we'll stick those down into our game code after we set up this, what I call it, print end screen. I think I called it print end screen. Yep. And we pass in win or lose, which makes it pretty easy. So all we're going to do here is sort of put some text on the screen. There's a lot of ways you could spice this up. But I don't really want to get too complicated here. I think the version that I put on GitHub is going to have this thing that I did where instead of saying you win or you lose, I think I spell you with the astronauts. It takes a really long time to blit all of those astronauts in position, but it looks kind of cool. So for this one, I'm just going to say print end screen and then a variable win or lose. And basically that parameter that we're passing in is just you win or you lose. All right. And what we'll do for this is super easy. We're just going to put a huge rectangle that basically is a pop-up over everything else. And it's going to say, it's going to be on the screen. We'll make the background black and we'll give it a white border, kind of like we did with some of the other stuff. We'll have it start at 50-50, and then we'll make it the width minus 100 and the height minus 100. So it's basically a pop-up that takes up the whole window with just like a 50 pixel border. And then we're going to make this same, Control C. We're going to make this same rectangle, but it'll just be white now. And we'll put it as just a border of 10 over that rectangle. So it really is just a pop-up window, and we're going to have it say, let's redefine the font now because we want some pretty big text for this. So we'll have the font equal to pygame.font, and then we'll have it say, it's still our font from before, so assets, and then sci-fi.ttf, I believe is the one we're using. And then this can be pretty big. We're going to make a font size of 380 because it can take up a lot of space. And we'll just say win text, or I guess it would be better to say end text. So we'll just say end text equals, and then it's going to be font.render. And we will just say win or lose. So the word that we pass in, like win or lose, let's do it this way. Let's say you and then space and then add win or lose. So that way if we pass in win and we'll put an exclamation mark in these guys, it's going to say you win or you lose using the same little easy formula here. And for all intents and purposes, the only difference that we need to do functionally is if you've won and you decide to restart, we want to check your time, check your score, and see if it's a high score. And if it is, we want to save it. But if not, I mean, your options when you win or you lose are basically play again or exit the game. So it makes sense to kind of do these as one rather than handling winning and losing separately. All right, so we're going to say anti-alias true, which someone on a past YouTube video pointed out to me just kind of smooths out the edges. I knew one of my viewers would know what it meant. I just always say I put true there. I don't even know what happens if you put false, but one of my viewers did, as I knew they would. All right, so let's blit this onto the screen, screen.blit, and we're going to put the end text, and we'll just throw it at like 100, 300, I guess. I think that'll look pretty good. Maybe it doesn't even need to be 100 over. And we're just going to see if that looks good. So you win, and then blit it onto the screen. And then I think we'll also put some other stuff on here. We'll say your time, and then we'll also say press enter to restart. So let's say enter to restart. And then this will say your time and time, just like that. And we'll make this an F string, and we'll get rid of this plus win or lose. All right, and now we're going to put end text 2 and end text 3 in some different spots. So if we put this at 70, 300, let's put this over at, gosh, I don't know. I'm just kind of guessing until we, let's put it over at 900. I'm just kind of guessing until we have a reason to play around with this a little bit more. So let's see. That should say your time and then enter to restart. And we'll just start there. So let's see. If I die real quick, is this going to pop up? I hope so. So 4 lives left. 3 lives left. I actually don't think I said when your lives go to 0, you lose, though. So let's do a few things that are going to make testing this a little easier. Let's kick lives down to 2. And now what I think we want to do is just in the main game loop, we want to come down and say if lives. So let's go into our main loop here. Game loop, and we can come down where we're colliding with acid, and we'll just say underneath that loop, we'll say if lives are greater than 0, then lose equals false, right? And then we'll say else lose equals true. And maybe it makes more sense to say if lies is less than or equal to 0, then lose becomes equal to true, but this is going to work just the same. So let's see. We obviously don't have the code in there yet for enter to actually reset things when you die, but let's see. If I just lose 1, 2 lives, let's look at the pop-up. Okay, so I'm going to go ahead and say 380 for text is a little bit big, perhaps a bit dramatic. Let's try something smaller. Maybe let's try 100 for the font in here. Let's just say 100. And let's go ahead and die again and see how that looks. I do want to stress, you know, I worked pretty hard setting up the style for this game. Your time 0, enter to restart. So what we'll do, we'll leave your time there. We'll scoot it to the left a little bit. So we'll say 800, but we're going to scoot enter to restart way over to 70 because that'll look better. I spent a lot of time on the main style of the game. I wanted it to look good for you guys as I did the tutorial, but these menus and things, you can play around with these a lot. I kind of like this. I think it's pretty good. You could improve it. You could move stuff around to where it makes more sense for you. But basically, this is good enough, in my opinion, to show you how you would handle like an end pop-up, an end menu. So let's go ahead and handle restart code, and then also how to check if win is equal to true. Okay, so let's go ahead down to where we go through the level. So you see here in this else, we have if active level is less than length of levels minus 1, then we add 1 to the active levels, and we set the phase equal to 3, and we clear the acid list out. Well, we want an else condition to that basically says else win equals true, right? And that's really all we've got to do, because everything else is fine. I mean, even if win equals true, when you go through a portal, all this stuff resetting is fine. It's just going to reset it to the level you're currently on, and then there's going to be this pop-up that all you can do is basically press enter for win or lose. So what's cool is because this is all going on under the if event key equals pygame.k return already, all we have to do is come down beneath this for and basically say instead of, you know, if the key is left and the key is right, then whatever, we can just come down under the if enter message and excuse me. So what we want to do is say if the event is pygame.k return and not win and not lose, right? So this if is saying, all right, if we press the enter key and it's not win conditions or lose conditions, do all of these shenanigans. And now what we'll do is we'll just put an elif that says elif key and then and win or lose. So we want this win or lose to be a separate from this and, so we're going to put it in parentheses. And basically what this is saying now is if I press the enter key and either the win variable or the lose variable are true, we want to do whatever we have to do to reset the code. All right. And this is kind of a few things that we want to do in here. First thing is we're just going to set active level equal to 0, because that means someone said they want to restart. Then we set active phase equal to 3. And then we set win and lose equal to false. So win equals false, lose equals false, because now we're resetting the game. Everything should go back to how it was. We'll reset the score, which is your time, to 0. Excuse me. And then we'll reset the level equal to levels at active level, active phase. So that should be old news to everybody. Active level, active phase. And then we are going to reset the inventory, clear that all the way out so that it's all 4 keys. It's basically like loading in a new level. It's just loading in the first level. And then inventory is all false. And then we're going to find our new position again. So I'm going to come and grab this for underscore all this init stuff here. Y change. Actually, I'm going to grab all this. We really can grab pretty much all of our reset code. Yeah, so let me see. We don't need this one twice. But yeah, basically it's all this same stuff, and then we'll reset the lives back to whatever the initial is. So I'll make the lives equal to 3. That'll be good, actually. Let me go back up top. I think I only gave myself 2. We'll say 3. Yep. Alrighty. So let's see here. That should be all we need to do to reset. Let's go ahead and try to die real quick and see if it lets me restart. I shouldn't have jumped. Now I'm not dying. And let's do it one more time. All right, I died. I press enter and I'm back. I've got 3 lives. I'm on level 1, phase gold. I assume if I had been on future levels, I would have come back to the very start. So it looks like our restart code is working. It looks like tracking if we've won and tracking if we've lost is working. So I think the next thing we should do finally is actually track the time as we're going. And to do that, let's just come up where we were doing the counter stuff. And we'll just basically say if counter, blah, blah, blah. We don't really care about that. We'll just say if not win and not lose. Because we don't want the time to keep counting after we've won or after we've lost. Your time in game is just while you're actively playing. And we'll just add 1 to time. And now I have something that I want to show you guys because it might look like I'm just doing kind of a shortcut cheat for keeping track of time. But basically, this timer.tick FPS is controlling the maximum speed your game can run at. But the actual runtime, so if I were to say, let's just so I can show you guys, the real runtime our game is going at is never going to be greater than our FPS, but it could be lower if you have a program that's using a lot of processing power. So actual FPS is going to be equal to font.render the string of, and then I'm going to round that variable real runtime because it's going to give me a lot of decimals. This is going to show you the actual FPS the game is running at. So round real runtime to 2 characters, convert it to a string, and then anti-alias is true, and I'm just going to make it white so that we can see it on the screen. And then I'm going to just put this in the top corner of the screen, okay? So screen blit actual FPS, and I'll put it at, I don't care, 1010, because I'm going to get rid of this in a second, but I do need to grab the font real quick. So let's grab this guy. Control-C. All right, and I want to stress, this isn't part of the game. This is how I'm explaining what we're about to do for the time. And this is also important. You may want to run this test that I just put in with this font, real runtime, actual FPS, and then screen.blit. Because basically what we're checking is, all right, we know we said we don't want it to run. Actually, I'm going to have to blit this lower than the screen.fill. Because I'm filling it with the background. I need to put this on over top of the background. All right, so hopefully if you're seeing my screen, you're seeing that I'm actually only getting around 20 frames right now, and most of that is because I'm running a video recording software and I have this game going. So actually my computer's struggle busing to run this. You're going to want your time elapsed to be based on approximately whatever your computer is giving you. So I can see mine's floating right around 20. So the math I'm about to do is going to be based on math with 20 frames per second. If you're getting like 60, then your math is obviously going to be 60 frames per second. But the reason I'm saying all this is because where we display time elapsed, you want it to basically be time divided by your frames. So we're adding 1 every frame, but the actual seconds is the total number of frames that's elapsed divided by your frames per second that you're running at. So if we come into the like draw inventory function where we display the elapsed time, it's around here. I know it. You guys probably see it already. Here we go. So time, we actually want to do time floor divided by 20 seconds. So for me, it's because my FPS is right around 20. It would really slow your game down to do timer.get FPS in here, but this would actually be fairly accurate, except that this floor division is going to give you an integer. So it's saying round down to the nearest whole number. And if you run that test that I just gave you and you see that your frames are around 20, this is going to actually show you your time in seconds. So if I were to run this now and you were looking at the clock, 1 second, 2 seconds, right? You can tell just from looking at it, that time is fairly accurate. Since I loaded this up, I've got a little counter going on how long I've been recording, and I can see it's been like 14, 15 seconds right on the dot. So that's why I'm doing time floor divided by 20. That's kind of what I recommend you do as well. And now let's take a look at something that's pretty important to creating a game that is actually fun and replayable, because like maybe you want to constantly be trying to beat your high score, which is what makes a really great game, like getting a high score, trying to beat your previous high score. And so to do this, you just want to drop a text file in your program, and mine's highscore.txt. If you downloaded the GitHub package for this project, I believe I included a highscore.txt, and I would just initially throw a 0 in there. The code that we're going to build should work even with nothing in there, so if it's just a blank text file, but I would just initially throw a 0 in there so you have an integer. And then the code for this is actually pretty easy. So if we come up to where we have this high score equals 0, this is going to kind of need its own section. So let's just say load in high score upon program start. So basically in the very beginning, we're going to check that text file for what our old high score was. And then when we lose or when we win, we're going to check and see if that beats the high score. And if it does, we're going to write back to the text file. So to do that, it's pretty easy. I've done this in a few past games. We're just going to make this variable file, and we're going to use the open command to open a file. Wow, this pop-up is really filling my screen. And then in open, you just say what file you want to open, and then you give it a command after a comma that's either R to read or W to write. Now in the beginning, we just want to read from it. So we'll say read equals file.readlines. And so that's basically the command that's going to read through whatever you have in your text file. And then we're just going to say if read, which is a list of all the files that we read as strings, at 0 is not equal to an empty string. So this is where I said it will work if you put an empty string in here, because I'm going to put in this, else high score equals 0 condition down here, just saying, okay, if there's nothing in there, then the high score is equal to 0. Otherwise, we want the high score to be equal to read 0. And then that's because that's going to be a string. We're just going to do this neat little trick, which is, okay, then we're going to make the high score equal to an integer conversion of whatever the high score is. And then very important, I don't want anyone yelling at me because I forgot to close my file. Make sure you do file.close after you're done manipulating the data in a file. All right, so in the very beginning, just to show you what's going on, let's say my high score was 1200. And just to show you this is working, if I boot this up, it now says best time is 1200. Now, I'm not too worried that that fourth character spills over, because I know this game doesn't actually take 20 minutes. You'd have to be above 18 minutes, I think, to get 4 characters, and then it looks too big. So 1200 was maybe a bad example. But you can see it's clearly working. When I boot this up, I changed it to 120 now. It tells us our best time is 120. So the whole time you're playing this game, you see that your time is going up, and you're like, oh, I've got this time to beat of 120, something like that. Okay. So basically, let's put it back to 0, and let's finish up with how to save if you get a high score at the end of your game. All right. So let's go down to basically where we restart, right? Where we press enter to restart, and when we have win or lose. And let's just come down and say, if win or lose, let's go to the elif and win or lose. And let's just say if win. So that means, you know, we're saying we're in this mode because we've won or we've lost, and then time floor divided by 20. So again, this is getting actual seconds, is less than our high score. Or I'm going to put another condition in here, because initially we're saying the high score would be equal to 0. So we'll say or the high score is equal to 0, or somehow the high score was empty. It was like a blank string. If any of those are true, then we're going to do this file equals open, and that same file that we had before, we're opening up the highscore.txt file. But this time we want a W here because we're writing to it instead. And we're going to set our high score variable equal to time divided by 20, so our actual true seconds that we've taken in the game. And then just do file.write string high score. Alrighty. And then file.close. And that's all it takes. So if you have an initial value of 0 in here and you beat the game and it's like 900 seconds, this program is smart enough to see that, well, that 0 wasn't a real score. That was just a default value. So it's going to write a 900 in here. But then from then on, it's going to try to see, did you beat that 900 this run? Oh, you did. You got like 880. Great. And then it's going to move that into the new high score. But then we're going to have this separate deal, which is like, okay, well, no, you got 910. That's higher than the high score we already had on file, so we're not going to bother with writing to the file. I think it would be better to set this up to where this check would run once when you get a win right away. But the reason I say only once is because you don't necessarily need it every single line. So I guess I will put it in here just to make it clear that this is not the right spot to put it where I had it. And we've come far enough, and this is a big enough project that I want to get this right for you guys. But boy, I'm getting tired. All right, so that should work. That should save our high score. Probably the easiest way to test that, I guess, will be I'll just load up what I think my last level is. I think my last level is 5. 5. So I'll just load up the last level, and I'll play it real quick, and I'll make sure my high score updates based on that. So I'll say active level is 5, active phase is 3, and then I'm actually going to give myself the gold key. So hopefully I can just run up and grab the gold portal. Actually, I forgot I got to play this whole one because I can only get there through the blue portal. That's good game design, Pete. Nice. Alrighty, so I got to get the blue key. And you can see, maybe there's some fine tuning you want to do on the style elements, but overall, these are levels I didn't have to take too long building because of, again, the great level editor that we put together. But now I'm going through the blue portal, and now I'm going through the gold, and this should win it for me. Bam. And it says my time was 678 because we forgot to update that to be divided by 20. But now I'll press enter. And there you go. It updated to say best time is 33. So what we need to do is we need to go to our draw end screen, which is around here somewhere. And we would just want this to be time divided by 20 as well. Alrighty, so that looked pretty good. I think the last really significant thing we haven't done yet is sound effects. And it's going to be actually, I think you'll be pleasantly surprised by how quick and easy it is to get sound effects. But let's go ahead and start by loading in all of the audio. And we're going to do that just under where we loaded all the images, okay? Because that is another big section. So we'll say load in music and sound effects. So it's not too hard, but you do just need to know the specific PyGame format for doing this. Format. And so in my assets folder, I have another section called sounds. And all of these, again, are royalty-free sounds. Most of them came from YouTube's sound library, including the songs. So you don't have to worry about any of the stuff I linked in GitHub getting you in any kind of copyright trouble. It won't. So to use the sound package in PyGame, you just want to start with this pygame.mixer.init like this, and then you want to do pygame.mixer.music.load like that. And now this is the actual background music, so it's a little different than sound effects. So assets, sounds, and then I think the one I liked the most was song 2, but you can play around. I put, I think, 3 songs that were kind of sci-fi space-ish from YouTube. I put them all in the folder. All you'd have to do is point this at song 1, song 2, song 3, whatever, or just pull in your own song. If you have a bootleg copy of the Beatles, you can just put that song here as the background if you really want. And then pygame.mixer.music.set volume. This is kind of important just for controlling like balance of your sound effects versus your volume. I'm going to set the volume to 0.2 because it's background music and you don't want it to be too super loud. But then I'm going to say pygame.mixer.music.play, and we're going to play it at -1. The reason for that -1 is you're putting in there how many loops to play it at, and -1 means infinite loops. So -1 means play it forever until you actually close the program out. So that's why the -1. And then we're going to have a couple sounds. I'm going to have a sound when you collide with the acid. I'm going to have a sound when you go through the portal. I'm going to have a sound when the game is over, which actually is kind of a gnarly sound. So I'm just showing you how to incorporate sound effects. If you hate any of my sound effects, just delete that line of code. Okay? And then I'm going to have a jump sound. And then I'm going to have a key sound. All right? And so these are all the various sound effects that you need for kind of the key events that happen in the game. There's other ones, and you don't need all of these, but these are the ones I'm going to show you how to use. So it's pygame.mixer.sound, and then sort of just like with the music, you just point it to the right file. So assets, sound, and then I called them pretty intuitively similar things to what they actually are. So I called acid, I called portal, I think fast whoosh, actually. But you know, because you go through a portal, it's a fast whoosh. So that's why. And then I think I called the end sound victory, but it's actually kind of an ominous, like, sci-fi screeching. So maybe that wasn't the best. Jump, I called leap, which is neat. And then key sound, I called key_acquire, which is at least kind of logical, I guess. All right, so we loaded in the files here, which is pretty groovy. But what you'll see now if I boot it up is the background music will play, so I'm not going to bother with that because I want to put the sound effects in at the same time. But really, the rest of this is just skillfully going down to our various events where, like, okay, we know what happens in check collision if we get a key, right? We acquire a key in where's check collisions? I think that's what I'm in here. Yeah, so these ones are going and acquiring a key, right? Setting something in your inventory equal to true. Well, we're going to do key sound dot play, just like that. And make sure to put on all 4 of them so that it plays when you get any of the keys. But just doing this, key sound dot play with the parentheses, is going to say when you grab any key, it's going to make the noise that you selected for key acquire. All right? And now let's go ahead and go to what's probably the next easiest one. If, when, print, end screen. Probably this one, because we'll just do end sound dot play, just like that. And we'll do that if lose as well, end sound dot play, just like that. And now let's go to, okay, we're walking, we're colliding with stuff. Let's go to the space bar, right? That's jumping. So if space bar and not in air, then we'll do, I think I called it jump sound, or did I just call it jump? Yeah, jump sound dot play. So that'll be the noise they make when you jump. Now let's go to the acid, where we check if the player collides with acid and loses a life, and we'll just say acid sound dot play. All right, so what else? Going through a portal, right? Teleporting. Let's see. So if I is not equal to 3, this is what a teleport is. We will do portal sound dot play. And then we'll do that as well when you load in a new level. I think that'll be pretty groovy. So we'll say else. And then this is saying you got to a new level. And we'll just play the portal sound. And something I did in playtesting that I kind of liked is I played that key acquire sound because it's kind of like a happy sound for whatever number of levels you were on. It might be a bit much if I played that while I was also doing the tutorial, so I'm going to leave it there. But let's see, are there any sounds that we forgot to do? I know we got the acid, we got the jump, we got the portal, we got the end, and we got the key. All right, so let's go ahead and playtest this thing. All right, and I guess, yeah, we'll start on this last level here. So let me go ahead and clean up a few things here. We don't need to display the frame rate anymore unless you're curious. You can leave it on for yours. But I'm going to get rid of those rungs where we were checking the actual FPS and everything. So I'm going to get rid of this. Just trying to declutter the code a little bit. And then I'm going to set myself back to level 0. Active level equals 0. And I am going to make sure that the inventory starts as all false. It'd be pretty boring if you started with the final objective every level. Okay, now I'm just going to play through the level and kind of talk about what I'm seeing. And you can hear the background music. I've got this jump noise. I think the background music's pretty sweet. Let's grab this key. Okay, that sounds pretty good. Let's go through the portal. There you go. Tell me that's not a sci-fi portal noise. All right, and now I've got this key card. I'm going through the portal. Tell you what, let's jump in some acid for that noise. I thought that was pretty good, kind of ominous. Alrighty. I like the key card. It's kind of like an uplifting noise. Alrighty. And now let's go back through blue, back to green, back to red. And let's go grab yellow. Alrighty. I'm not going to play through the whole game because I built the game, but trust me, I've beaten it several times. My friend Dale has beaten it, so I know it's beatable. My wife hasn't beat it, but she's bad at all video games, so that's not surprising. So I hope if you guys decide to grab the whole project from GitHub, and maybe you just want to start by playing the game, seeing what's all about, and maybe that gets you kind of curious, then I hope you enjoyed the tutorial. If you really stayed through the whole thing, I mean, I really appreciate you being here. I hope you learned a lot. If you have any questions about what you saw in this, or you want to see something specific in a future video, just be sure to let me know about it in the comments below. I will get back to you as soon as possible, and if it's a good idea and a lot of people like it, then we'll probably do a tutorial on it. That's how we ended up with a platformer in the first place. I'm not that good at this game. So as always, thank you guys so much for all of the support. Thank you so much for checking out the channel. If you liked this content and you want to see more like it in the future, consider subscribing to my Patreon. Don't forget to subscribe to the channel, leave a like on the video. Those things help me out a ton. Sincerely, thank you everyone who's been here to support me. 1 year of LeMaster Tech. It has been a great year, and I'm looking forward to seeing what kind of projects we do in the coming years. And as always, thank you guys for watching, and good luck with your projects. Thanks. Bye.